Good morning, everyone. My name is Colin Graham, and I work in the Technical Advisory Unit within Invest Northern Ireland. I'd like to welcome you all to our CE Marking Mechanical Engineering webinar, which will be focusing on the requirements of the Machinery Directive. This is the second in a series of 3 half-day webinars that we're running this month. So hopefully you'll find it a convenient format and a pretty practical half-day event, and we're very pleased to be able to provide it for free. We've got almost 100 people registered to join us online this morning from a wide range of companies from right across Northern Ireland, and we've even got people joining us from England, Canada, and India, so welcome to everyone. This morning, we're going to go right through until about 1 o'clock, but we'll have a break around about 11 a.m. If you have any questions at any point during this morning, please enter them in the question tab at the side of your screen, and we will pause at the end of each section and round those questions up and try to answer them as well as possible for you. The big question everyone asks is, will we get the presentation? And yes, you will. We will hopefully email the presentation and the webinar recording to you as soon as possible after we finish today, so look out for that coming through to your inbox. Our main presenter today is my Invest-NI colleague, Pierce McAnallen, and Pierce will be supported by another Invest-NI colleague, Jackie Curley. Pierce is a mechanical engineer who's worked in a number of major manufacturing and service industries. He joined Invest-NI 17 years ago, and since then he's been working extensively on helping Northern Ireland companies to address the requirements of the machinery and other directives. So he has a lot of strong practical working knowledge of CE marking in today's complicated world, and he'll bring that practical knowledge to the session this morning. So we'll hope you'll find the morning useful, and I'll hand you over now to Pierce to get us underway. Thanks, Pierce.
Good morning, folks. As Colin says, my name is Pierce McAnallen. I'm a technical advisor in the Technical Advisory Unit within Invest-NI. I'm a mechanical engineer by background, and I have a good number of years of working with a lot of companies. I've probably met a good few along the way on CE marking and related directives. So as I said, it'll be myself doing most of the talking today, and then my colleague Jackie Curley is doing a piece in the second half of the day. So just to give you an overview of excuse me, the agenda as such for the day, we'll try and stick to this as much as we can. So I'll be talking up to 11 o'clock. We'll have 2 question sessions before that. Please drop the questions into the chat, and Barry then will manage on the questions for us. And then, as I say, we'll try and answer the questions as I go along, and then say we'll have a break, and then we will have another session with a couple of question sessions during it, and then we'll wrap up for 1 o'clock. So as I say, any questions during the day or any final questions, you can send them to us. And also as well, my details will be available at the end, so you can send me questions or queries directly at any time. So I'll make a start on what we're going to talk about. So first of all, I want to talk about the background to CE marking and also the other marks that you will see around there, the UKCA mark, which is relevant in GB. So what is CE marking? Well, CE marking is the only obligatory for products for which the EU specifications exist and require the affixing of a CE mark. That's one of the big questions we always have, is can I not just put a CE mark on it? Well, unfortunately, no, you can't unless you have a directive which requires a CE mark, and I'll talk through some that do and some that don't. It should be affixed by the manufacturer, authorized representative, and by affixing the CE mark, you indicate that you're taking the responsibility for conformity. So CE mark is almost like a promise. If it's the Machinery Directive, which is a self-certification directive, you're almost making a promise that you are certifying it, and you have to back that up. It's forbidden to affix the CE mark, as I said, for that don't require it, and some products are subject to several directives, regulations at the same time, and you need to comply with all of these before you affix a CE mark. And again, I'll give you examples of those as I go through. So what is the UKCA mark? Well, the UKCA mark at the moment is pretty much identical to the CE mark as far as the technical requirements go. It has so it only applies in GB, England, Scotland, and Wales. It doesn't apply here. It's been in since 2021. And you will have seen it. It applies to most products that the CE mark applies to, and you'll have seen it in the likes of Baxa TVs, power tools. You do see dual mark on it. By following designated standards which the UK introduced, there's statutory presumption of conformity. So it's the same as CE mark, and it's that presumption of conformity if there's not a notified body involved. And for products that can use a CE mark, a UK CE mark in Great Britain, these must meet EU rules in Northern Ireland and EU, including the CE mark. So UKCA alone is not sufficient for Northern Ireland. So just across the jurisdictions, this is kind of an old piece of guidance. I was looking up the current guidance. It all is the same, but this kind of lays it out probably graphically best. So goods placed on the market, it requires a CE mark. There is another mark which has been around but isn't used. It's called the UK NI mark. It's only if you're placing the goods in Northern Ireland only, and you must CE mark as well. So I've never personally seen it used, but it does exist. It does exist on food and other things. There is a UK -NI mark on food, etc., and other products, but as far as machinery goes, I've never seen it used. I mean, I can't think of a good reason why you would want to use it. Goods placed on the market in Great Britain are UKCA or CE. That was up until the end of 2024. They were agreeing to accept CE marking, but that has been extended. GB has extended its acceptance of CE mark, and that's currently still the situation. And we'll talk later about some of the changes that are coming potentially with the machinery and how that's going to affect GB. So placing qualifying goods in Northern Ireland, qualifying Northern Ireland goods to be placed on the GB market in unfettered access, it's basically a CE mark. And again, placing goods on the EU market is a CE mark. So the CE mark is kind of king in all the marks at the moment. Again, this is a piece of guidance from the government. The guidance is slightly different today if you go onto the website, but basically what it says is that they will accept CE marking beyond 2024. And this, they felt, was to help with ease businesses, GB businesses to continue to grow, because the difference in the marks was causing businesses some issue. So that's kind of the history of UK and CE marking. One document that I find useful for companies, sometimes with your European customer, you'll find that they will potentially could query and say, oh, well, a Northern Ireland manufactured product is not made in the EU, therefore you can't CE mark it without an authorized representative. I always find this document answers that question. So this is from the European Commission, and I've highlighted a few areas in it. So basically what it says is products placed on the market in Northern Ireland have to comply with applicable EU legislation. A product manufactured in Northern Ireland and shipped to the EU is not an imported product for the purposes of labelling and identification of economic operators, responsible persons. So in other words, it is deemed as an EU manufactured product. And then also importers, authorised representatives and other responsible persons may be established in Northern Ireland. In other words, you can write your own declaration of conformity. You don't require an authorised representative. Unfortunately, manufacturers in GB do, because they're not deemed as being authorised to be their own authorised representative or the manufacturer. So we're allowed to CE mark our product, and we don't require an authorised representative. So moving on then, which directives apply to a product? So this is always kind of the question you get is, how do I understand what my requirements are? So what you've got to determine is which directives, and more than one can apply, and then how you meet them. So common directives that are out there that you would see a lot on machinery is, and they're like the ones that are likely to require CE mark is machinery that we're talking about today, low voltage radio equipment, construction products, that's the likes of steel, lentils, windows, doors. You'll see a lot of that. Pressure equipment, again, depends on the pressure, but you will see that on the likes of tanks for compressors, etc. The things that we would see. Medical directive, again, lots of medical devices, and toy directive as well. So they're quite likely to have a CE mark on them. So there are products that don't require a CE mark, but this is always the thing. Even though you don't require a CE mark, that's not the be all and end all. What I would say is there's always something that will apply to your product. So the one that catches is kind of the catch-all, and it's had quite a big update recently, is the General Product Safety Directive or the General Product Safety Regulations. That is the catch-all, and everything falls under it, and a lot of things fall specifically under the General Product Safety, and again depends on your product, but you don't put a CE mark if it falls exclusively under General Product Safety. And then the other one that I get asked that I deal a lot with is vehicle directives. So vehicles don't require a CE mark for the vehicle purposes, that you'll see a small E or a big E. So if you look on your headlights, if you look on your vehicle, if you look on the plate in your vehicle, you'll see an E mark. Now, vehicles can be both. Vehicles can be a machine and be a vehicle. So for example, a tipping trailer would be the obvious example. It's a vehicle, so all the running gear, etc., will fall under the E marks and the couplings, all that. But the actual tipping, the tail door, the hydraulic tail door, beaver tail ramps, they fall under machinery directive. So you'll end up with both a CE mark and an E mark on a trailer like that. So again, that's where multiple products can apply. So we always have a quiz. It's a very easy quiz, this hopefully, but when you look at a product, you'll say, well, how many of these require a CE mark? Tractors are pretty dangerous things. Big curtain sider, semi-trailer, skip, they're all dangerous things, and you have the cuddly teddy bear. But the only one of those that actually will require a CE mark that falls under directive that requires a CE mark is the teddy bear. It falls under the toy directive. Again, the trailer is vehicles. The skip is not deemed as a machine because there's no moving parts. And the tractor, although it is a machine, there are specific directives around tractors. So you'll see as they're category T1, T2 tractors, and there are specific legislation around that. And you can see CE marks sometimes on things on tractors and in tractors, and that's different. But the actual tractor doesn't fall under a directive that requires a CE mark, but it does have a lot of legislation related to it. So again, the question is how many require a CE mark? And again, when you read the definitions, so the excavator does, because it's deemed as a machine. It's different from a tractor. It's deemed as a machine. And the lifting equipment and lifting attachments fall under, although there's no moving parts in them, and I'll go into even more detail on that again. Lifting equipment and lifting attachments do fall under the machinery directive. This was brought in a number of years ago because there really was no home for them, so they put them in under the machinery directive. Again, a bicycle is human powered. Now I know there are e-bikes and stuff out there which do, because if they're motorized and they have power source other than human, they would. And again, then a tipping skip, a manual tipping skip doesn't, but there is specific requirements around that. Again, just because it doesn't require a CE mark doesn't mean that you don't have to do something. Kind of a trick question here, how many require CE mark? Well, you'd say, Pierce, that's the same picture. Why are you showing me this? But sometimes it depends on the environment it's going into. Sorry, just go back to that one. So climbing frames in a domestic environment fall under the toy directive and do require a CE mark. Climbing frames in a commercial environment fall under a specific standard, 1176, and do not require a CE mark. So the same product can require a different mark depending on its intended use or environment. So again, it's that thing, you have to do the research on your specific environment. That's a very unusual one there, by the way, but again, it's just one of the quirks that's there. So that's that. So, and then some products, again, everything has to be safe and does require you to do lots of tests and lots of evaluations, etc. But there are some products where you will find specific HSE guidance, and it's same with the HSA down south, etc. And in Europe, you will find specific guidance. So work platforms non-integrated on forklift trucks is quite a common one you'd see in the market here. They don't require a CE mark, but there is a very specific guidance on them, and that's based around how you chain onto them, how the door works, how the gate works, sorry, on them and stuff. So there's very specific guidance, but no CE mark. And I have seen these CE marked, but that's incorrect. If it's non-powered and it's non-integrated, in other words, it doesn't work from the forklift, it's only lifted by the forklift, then there is a specific set of guidance. So we get to the common misconceptions, excuse me, and we're always asked about these. And it's very interesting when I get asked the same questions a lot of the time. But if there's a CE mark on it, it's safe. Well, no, because I think I have 160 odd slides, and I have 2 slides on how to affix the CE mark in this presentation. It's just putting the CE mark on it does not mean that something's safe. Now, that depends who you're getting it from. If you're getting it from a reputable company that you've worked with for years, you can assume that they are meeting their legal requirements. However, if you're bringing something in out of China or other countries like that, you probably need to do a wee bit more due diligence to satisfy yourself that it's correct. And the other thing is CE plus CE is not a given. It doesn't mean just because you take a number of components that are CE marked and stick them all together that it is your actual end product is CE certified. You have to look and assess the overall project that you're dealing with to ensure that it is, that it does meet the requirements. Example, in an electrical situation, if you were to put together contactors, switches, etc., and one of those is totally underrated for the motor, well, that doesn't mean that that product then is safe because you're going to blow a contactor or you're going to blow the motor or whatever. So you have to assess the products that they're all suitable to be interactive with each other. And then this is probably one of the most common things I come across. Be aware of advice from non-committal experts. And there are lots of people out there, and I go visit a lot of companies to say, a man told me, somebody told me, and I'd say, well, did he write it down? Did they give you some sort of piece of evidence to say that you didn't need to do that? So if someone tells you you don't need to do something, or you do need, you want to back that up with some knowledge. Evidently, if you're paying a company to come in and help you with CE marking, they are a committal expert. But it's the non-committal experts who give you advice, who won't be around if anything goes wrong. They'll certainly not be about to help you out. So just beware is all I would say of those. So we're going to move on then to the compliance process. How do you actually start to comply with your product's requirements? And I suppose the first stage of that is you identify the applicable directives, regulations, and harmonized standards that apply to your product. You then verify the product's specific requirements. So again, the whole regulation, the whole standard won't cover you. You're picking out the parts that are specific to your product. You then identify whether you need a third party, an independent conformity body. With the machinery directive, that is the good thing about it. You generally don't tend to require it. That's the good thing. But there are some cases that you do, or parts of your products do, and I'm going to talk later about the new machinery regulation, and there's probably more stuff coming in that will require a notified body. You then test the product to check its conformity. In other words, you carry out whatever tests you need to do, and that can be formal testing, informal testing, etc. You need to ensure that your product goes out safe. You compile and keep available the required technical documentation. So we'll talk about what's in the technical file later and what you have to do. You issue a declaration of conformity or declaration of incorporation if either are required. Again, under machinery, one of those is going to be required. And then you apply the CE mark if your directive requires it. So if your directive says you need a declaration of conformity and a CE mark, you put it on. But if it's a declaration of incorporation, there's no CE mark. And again, we'll cover that later. So approval routes. There's 2 routes really. It's self-certification. So with machinery, it's generally mostly anything I've seen made in Northern Ireland. I don't believe I've seen ever third-party stuff, and I'll show you the list later. Pressure equipment, a lot of it is, but not always. Some of the higher pressure stuff isn't. Toy directive can be a lot of self-certification, and general product safety tends to be, but there is some stuff that doesn't. And again, I keep saying there is, there isn't. Again, that's where you need to determine what your product requires. So third-party approval is common with the EMC, electromagnetic compatibility. Radio equipment directive can be common enough. Again, you can be buying in stuff and integrating it into your equipment, which is third-party approved, EMC and radio equipment. That's fine. Construction products tend to be, there's a very low level which isn't, but most of those are third-party approval. So if any of you are involved in structural steel manufacturing, you've been through the pain of getting certified for it. And again, then medical directive is quite a common one, where medical devices are third-party approval. Again, the higher the level of product, the more kind of rigorous certification and the testing, etc., is. So I'm going to give you an example of a product which falls under multiple directives. A common one, again, we all have them in our buildings, but they fall is the roller shutter door. So it falls under the machinery directive. It'll fall under the low voltage directive because it's going to be either 240 or 415. And it also falls under the construction product regulations, which does require third-party approval by a notified body for those bits of it. And there's two common standards. Just to give you an example, there are a number of standards, but two of the common standards for roller doors are the ones that I've listed there. So again, your declaration of conformity, you would actually have a declaration of performance under a construction product, so you're going to be issuing a number of certificates. So it just shows where two of those directives don't require third party, one of them does, and then you have a number of standards. So again, you have to determine what your product requires and how you meet those requirements. So when can machinery directive require third-party approval? There is a very specific list. There is 23 of them, apparently. A lot of it is to do with saws and stuff like that, so you will see that, chainsaws, car lifts. There's a list there. You can read the list at your leisure. Very few products in Northern Ireland manufacture these, very few companies manufacture these products. I have seen a couple of rollover protections which will fall into I have seen a few of those manufactured in Northern Ireland. So again, those fall into that where you would need third-party approval. So we'll actually get in now to the detail of the machinery directive and what's in it and how potentially it can, how you apply it and what's covered, etc. So we'll get a wee bit more specific now. So the machinery directive applies to the following products: machinery, obviously, interchangeable equipment, some safety components, lifting accessories, as I talked about before, webs, chains, shackles, etc. There's a whole raft of lifting accessories, chains, ropes, webbing, removable mechanical transmission devices. The obvious one there is a PTO shaft, and also partly completed machinery. And again, we'll talk about those as we're going through them. So, definition of a machine. A machine under the machinery directive is an assembly fitted with or intended to be fitted with a drive system other than directly applied human or animal effort, consisting of linked parts or components, at least one of which moves and which are joined together for a specific application. Now, I'm sure somebody sat up at night and thought that definition up, but really what that says is there needs to be moving parts and it needs to be powered by other than human power or animal power. So, for example, a horse and cart, the cart would fall under because it's animal power. An ordinary bicycle does not fall under the machinery directive, again, because that is human power, but as we know, there's lots of e-bikes, etc. out there now, which have kind of changed what a definition of a bicycle is. So that's the broad definition of a machine. So interchangeable equipment. Interchangeable equipment means a device which, after placing into service with the machinery or tractor, is assembled with that machinery or tractor by the operator in order to change the function or attribute a new function insofar it's not equipment or tool. So in other words, things like a link box, things like potentially a plough, it changes the function of a tractor, and an operator puts that device onto the tractor. That's a common one. Excavators as well, not a bucket, we'll talk about that in a minute, but a grab or something would be interchangeable equipment. So you can take it off and you can put a different piece of equipment on. What is a tool? Well, there's no formal definition of a tool in the machinery directive, but the nearest I could find to it is a tool normally means a terminal part of a machine in direct contact with the part of the material to be worked on. The obvious one is a bucket on a digger, a normal standard toothed bucket. It comes into contact with the material being worked on, and it's at the terminal part of the machine. It's out at the end of the arm. There's other examples too. General tools do not have an inherent risk, and moving parts are by direct human effort. So in other words, there's generally no moving parts on them. They are just a fixed bucket as such. Tools do not modify the basic function of a construction equipment to which they're fitted. So a standard bucket, that's what a digger uses. But if you then put a grab or a shear grab or something, or a tree shear on the end of it, that's different. That's not a tool. That's interchangeable equipment. That's the difference. So partly completed machinery then is the other one. So partly completed machinery, it cannot perform the specific application itself. A drive system is partly completed machinery. Partly completed machinery is only intended to be incorporated or assembled with other machinery or other partly completed machinery, thereby forming machinery which is machinery and machinery directive. So again, it's quite unusual that it basically partly completed machinery will sit there all day long and not work until you put the power source to it. Probably an example of one is if you were building skip beds for lorries where you set that whole bed on, and until it's fitted onto the lorry, it doesn't. So you would send a declaration of incorporation with that, and then the manufacturer the coach builder would issue the declaration of conformity. So again, partly completed machinery cannot fully comply with the thing. So therefore, the fact it's not a machine as such, you have to treat it differently. Therefore, a CE mark is not applied at that stage. It's applied whenever it goes into service. However, the only difference, I suppose, I would say, is the two differences: is declaration of incorporation instead of declaration of conformity, and there's no CE mark on it. The rest of the directive, standards, everything applies. You treat it exactly the same. It's just you don't put a CE mark on it. Your end user puts a CE mark on it, but do not think it's treated any differently. It's actually more difficult to deal with a partly completed machine in some respects. So partly completed machinery, the manufacturer must complete or is authorized representative before placing it in the market. So again, you have to complete the technical documentation. You have to have a more rigorous assembly instructions and the declaration of incorporation drawn up. The assembly instructions and DOI, declaration of incorporation, shall accompany the partly completed machine until it's incorporated into that final, and then that becomes part of the end technical file. So as you can see, I'm kind of stressing this, is it's partly completed, therefore you have to ensure that you tell the end user how to complete it and add it in. There's a bit of a flow chart and a few examples, so I'm talking away here, but maybe the pictures describe everything I've just said a lot better there. So again, a tool is your bucket office, skid steer or telehandler or excavator. Interchangeable equipment is your bale grab, your tree grab, your tree shear, etc. And you kind of have to do. So basically, does it have moving parts except for human effort? So no, that's the buckets at the top. They're straight to tools. Yes, they do. And then it's a case of who assembles it, if the operator assembles it. So if it's not assembled, in other words, it's still partly completed machinery. But interchangeable equipment is not partly completed machinery. The likes of the bale grab, etc., would go out with the CE mark because it's interchangeable equipment. You know that you quickly hook it on and it becomes part of the tractor or loader. Don't start sending out bale grabs or things like our PowerLink box, etc., with declaration of incorporation. They are interchangeable equipment. So safety component, again, no one probably makes them here. Maybe a few do, but people will buy a lot of them in. So fixed guards that you would buy in for it. There's lots of things there that are included as safety components. I'll not say too much about them. There is a list. Again, the rollover protection may be one that some people are manufacturing here. So there are a number of safety components which are listed under the machinery directive. So the working group for the machinery directive does issue guidance now and again, and does issue some guidance. And for lifting accessories, they kind of give a list of what is deemed as lifting accessories. Excuse me. So a lifting accessory means a component or equipment not attached to the lifting machinery, allowing the load to be held, which is placed between the machinery and the load. So it's the bit in the middle, it's the chains, etc., in the middle, or the load itself, or which is intended to constitute an integral part of the load. So if it's built into the load, it's not a lifting accessory. Lug eyes would be the obvious one. If you place number 6 there, a lifting eye, a lifting lug on the market, you would have to see market as a lifting accessory. But if you weld that in to where it's actually welded into a piece of kit, it's not. It's deemed as part of the load, so that's treated differently. Still has to be safe, still has to be, but it's not. Doesn't have its own declaration conformity. So again, they do give some good guidance on what is covered, and then on the next page, a lot of things that aren't. So for example, your bulk bag isn't. It's not deemed. It's kind of seen as a one-off use, so it's not covered. Cargo nets, stuff like that. The other common one then, I suppose, is skips. Everybody asks about skips, and I mean there is specific guidance on skips. There are standards around skips, but they are deemed to be the load. The chains that lift the skip are different. They're the lifting accessory, and then the lifting equipment is the skip lorry. So you have three different things, but the skip is deemed as part of the load. Still has to be safe. You still have to, because you have lifting lugs on it, you have to ensure that they're correctly fitted and they're ongoing, correctly used properly. So that's lifting accessories. As I say, there is a bit of guidance around that, which is quite useful. So just before we come to our first set of questions, there is specific or quite a very detailed guidance on the Machinery Directive. So the Machinery Directive itself is about 170 pages, but then you have this guide to machinery, to the application of it, which is 442 pages. It's a good bedtime read, but the good thing about it is it does answer a lot of specific questions. You can download it for free. I have the link there, but if you just type in Guide to Application of Machinery Directive, this document will come up. You can freely download it, and it is quite a useful tool to answer some specific questions about the Machinery Directive and CE marking. So that's the first part, and we're coming to the first part of questions. I don't know if there's anything in at this stage, Barry, or not.
There isn't, Pierce. Well, there was just one question, but I think someone maybe joined late, and it was just in relation to copy of slides, etc. Because I know there's a couple of links in your slides as well. So just to reiterate, post-webinar, we are recording this session, so you'll get a copy of Pierce's slides and Jackie's slides, along with a copy of the recording once we've got it processed and uploaded. But if anyone has any questions for this first session, if you want to quickly pop them into the chat, there will be other opportunities as we go through to ask questions. So I'm just keeping an eye on at the minute, Pierce, and we have no questions in yet, which means you're answering everybody's questions in your presentation. So we're all good. Are you happy if we move on to the next session? And I'll keep an eye, and if there is anyone else any questions in the meantime, we can gather those for the next bit. Yeah,
so we'll be stopping. The way we're going here, we'll probably be stopping before 11. So we can take the questions at that stage. And again, anyone, just if you have any questions, don't be afraid to pop them in, no matter how unobvious or obvious they seem at the time. So do pop them in, and Barry will track those. So we'll do that. Okay. I am going to move on then to the technical file. So what I'm going to start to talk about now is what's in a technical file, what the contents are, and then I'm going to go through each one of these individually, and I'm going to give a wee bit more detail on what's in them. And again, so for the purposes of it, these are the things that are in a technical file, and you can see general description of machinery is the obvious one, your drawings, your calculations, your tests, the essential health and safety requirements, which again is a very specific thing that you need to do, and I'll talk through that. Risk assessments. There are a number of methods of how to do risk assessments. I'm going to talk through the method that I use, or I would talk companies through. There's lots of them. There's no right or wrong, as long as you are using a risk assessment that can identify risks. So standards, we'll talk about standards, the different types of standards, what are standards and how you apply them. We'll talk then about technical reports and certification. So again, if your machine's getting tested, or if there's any specific test being done, even though it's not a notified body, but if there's any tests you're getting done. So then instructions for machinery, how you write instructions, what should be in them, things like that. Supplementary information, other things that you would get along, that you would send along your machine, other manuals, etc. from your suppliers. Declarations and marks, how you create a declaration of conformity or incorporation, and how you actually correctly apply the CE mark. Again, I have 2 slides on that out of all these. And then we'll talk about the manufacturing process, and that's where Jackie's going to talk a wee bit about that, about what you do in the manufacturing process. So I'm going to talk through all these and how you construct your technical file. Thing to remember is your customer does not get your technical file. Your customer gets some things that are in it, but so your customer gets the machine, they get a declaration of conformity, and they get a CE mark, and they get a set of instructions. They don't get your risk assessments, your standards, your technical report. They can request some of it, they can ask to see it, and that's not what it's there for. It's yours to, so you prove conformity, and if there ever was an issue, then the HSE, HSA, or any of the European authorities can come in and ask you to see it, and that proves your conformity. So it is a file. It literally is a file. I've done the old-fashioned file structure that we used to use. Those days are probably gone, but it makes sense to me. So you literally have a section for each of these. Some of them will be stuffed full. Some of them will have very little in them. And again, most of them now will be digital. You're not going to print this all out and keep it. Some people will, but a lot of it is going to be where you are going to keep this digitally on file. So first one, general description of machinery. What is it? Well, it is literally just what is the machine, general description, overall drawing, a high level drawing of the machine. Again, if it was a machine with extra conveyors or whatever, you would put those, kind of show those in the graphics. Overall drawings of machinery, and then drawings of control circuits, hydraulic circuits, pneumatic circuits, anything, any kind of pertinent description and explanations to understand the functionality of the machinery. So again, if there's something unusual about the machine, about how it's set up, how it's used, the environment it's in, stuff like that there would be in it. So that is one of the, it's a general thing. If I opened your technical file, if I'm a new engineer in your company, or if I'm assessing you, or if I am from the HSE, that I get a quick overview of what your machine is and I understand what it's doing. Again, if we're talking about a bale grab or something, it's less than a page. It's a picture and a couple of circuits and stuff, and that's what it is. So then the next section is your drawings, your calculations, your tests. Again, you don't have to structure it exactly like this. You may have drawings all in the first section. You might have calculations in the second. It's totally up to you, but all of these things should exist somewhere. So full detailed mechanical drawings, and that's as many as you want. But again, you wouldn't print them out. At the end of the day, today with modern packages like SolidWorks, you have drawing upon drawing, and you can print it out. You can have 3D versions of it. You can have section versions, but they do exist, and you have a numbering system, and you can call up any part of that drawing that would be required. And the other thing is you do have some way to control those drawings. So you have some sort of change management system, so that if I'm a new operator on your line, that I'm constructing the machine to the latest set of drawings. So that's one of the things you do need to control. And then technical information required to check the conformity of machinery with the essential health and safety requirements. So again, any calculation notes, and I say to people, this is your own notes. Some people have literally done out a page, like say they're determining the size of pin they need to use. They can do a quick calculation. They might run that in the very basics of the basic kind of analysis software bit in SolidWorks. That's fine. You can keep a note of those. And again, any kind of test reports, including videos, photos. So in other words, if you are testing, doing dynamic testing on a block grab, for example, you can video that test, and you can video the before and after, and you can video around your wells and stuff to show no cracks. So yeah, videos, photo evidence, all can be kept there. And then any kind of certificates. If you are getting a certificate for something like again, this can be supplementary information, but if you were getting a certificate with your power pack, or you're getting a certificate with your panel, you can keep all that in there, keep it all together. Again, as long as you know where it is probably an important thing. So quite a long one then is the essential health and safety requirements. So this is something that is in the directive that you need to cover off, and you need to go through them. There are 6 sections. Generally, you only need to cover section 1. And there's 7 parts to section 1. So I'll go through all of these in a bit more detail. So the HSR say the responsible person must ensure that risk assessment is carried out. So it tells you need to do your risk assessments. The machine must be designed and constructed taking into account of the results of the risk assessment. In other words, if you do a risk assessment, you realize you need a guard, you need a step, you need something, you must design the machine to incorporate to remove that risk or minimize that risk. And by the iterative process of risk assessment and risk reduction referred to above, the responsible person shall determine the limits of the machinery. So again, you determine what load it can carry, what load, it can be attached to it, what it's capable of lifting, identify the hazards that can be generated, and the associated hazardous situations. So for example, an excavator sitting there isn't dangerous, but if you start to move an excavator, you have to think of the landscape you're in, you have to think of who's around you. You eliminate the risks, taking into account the severity of possible injury, damage to health, and probability of its occurrence. We'll talk about how to do that later. Evaluate the risks with a view to determining whether risk reduction is required. You don't always need to do something about it. Well, you always need to do something, but it's what level you need to deal with that risk. There is risk with machinery. It's just how you minimize that risk. And then it says eliminate the hazards or reduce the risks associated by these hazards by protective measures. So you always try and eliminate first, and if you can't eliminate, you then protect against it. So there are 6 sections to the essential health and safety requirements. They're all in the directive. You can download the directive for free, and in the guidance document on the machinery directive, it gives you a lot more detail about these. Thankfully, most of people listening today only have to do the general. You're not involved in food stuff or medical, mobile machinery. Some people may be involved in that one. Again, anybody that maybe the likes of bedding machines or something like that, there or something you sit on, that would fall under mobile machinery. There's a lot, I suppose there are some people now building various small versions of skid steer type products, so those do exist. Lifting equipment, again, that's not lifting attachments, that's lifting equipment. And again, underground machinery, don't know of anyone doing that, or lifting or moving persons. So there may be some people do that. So most people, and I'm going to focus today on number 1, the general requirements. So again, when you go into general, then as I said, there's in that first part, there are 7 main parts. There's the general remarks, which you need to adhere to. Talks about your control systems, protection against mechanical hazard, required characteristics of the guards and protective devices, risks due to other hazards, and then your maintenance. So in other words, no machine is safe unless it's maintained correctly, and you as the manufacturer must tell people how to maintain things correctly. And then your general information, which will be your signage, your manuals, etc. So those will be on it. So then we'll go in a wee bit more into each one. And again, I'm going through these, and again, you will get a copy of the slides and stuff. I'm going to go through them quite quickly. But what I would say is, it's up to you to maybe come back to this and look at it in more detail as to what you're doing. So as I say, I'm going to go through them, but feel free to go back over them in more detail. So general remarks, definitions, principles of safety integration, materials and products, lighting. Again, if there's no lighting in your machine, it doesn't apply. Design a machine to facilitate its handling, ergonomics, operating position, and seating. Again, if you have no seat on it, it doesn't apply to you. And then 1.2 talks about control systems. So again, what sort of control systems have you on? Control devices. It talks about starting, stopping, and again with stopping, there's a normal stop, there's an operational stop, an emergency stop, and then there's assembly of machinery. What it's meaning by that is if you stop a machine in an operational stop, you normally would just start it from where it sits. But if you start something in an emergency stop, you may need to go back to the home position. So you have to think about your starting and your stopping positions and there's lots of detail in there as to what is a starting position, what isn't a starting position. So again, you just have to go through these and do it. And later on in some of my examples, you'll see where I have covered off in a few of these. But it's quite a detailed document, and it does give you reasonably good guidance. And a lot of it will be not applicable, Failure of power supply is always an interesting one, and I suppose failure of power supply is if your hydraulic pump goes down, is there a way that machine will stay up? There's probably another, and then again, electrical supply. If your electrical power failed, does that machine come crashing down? Or the air supply, if the air supply failed, I had once one of the machines I built a number of years ago, and we had a dump valve for the air, and when we hit the dump valve, we decided not to dump the valve out of one section of the machine, because otherwise a head in it would have come crashing down. So again, you maybe want to strategically look, if your power fails, what do you hold up, what do you not hold up? So again, it's all about control. One a lot of people, or I suppose everybody on here is probably dealing with, is protection against mechanical hazards. So loss of stability, loss of brisk breakup during operation, falling or ejected objects. I suppose a lot of people in the crushing and screening industry would have to deal with that, again in the agricultural industry as well. We all have to deal with risks due to surfaces, angles, edges. So again, I know you all buff off your angles, edges, but again, something that somebody could walk into or whatever, or catch their hand on. It's covered, it tells you how to do it. Combined machinery, again, if you're putting two bits together or two products are running together, how does that affect your risk? Variations in operating conditions. Well, today is a lovely frosty morning, and if people can slip and slide around that machine, is that something you need to look at? Or again, if your machine runs and it's running wet material and everything's getting wet, your operating conditions are changing. Risks related to moving parts, there's more detail about that, but again, that's the moving parts is always the enemy, I suppose. And then it's your choice of protection, moving transmission parts or moving parts involved in the process. So again, it doesn't just talk about moving parts, it gives you different types of moving parts. Again, a transmission part is normally something that's rotating, whereas if something's moving up and down, that's a different sort of guard you're required in that. And risks of uncontrolled movements, again, that can happen for various reasons, but how do you guard and mitigate against it is one of the questions that you have to answer or mitigate against. And then it talks about the characteristics of guards and protective devices. So you have your general requirements, which I mean they all have, and then special requirements for guards. There are some fixed guards. So is it bolted on, welded on? That's a fixed. A fixed guard is something that is fixed and is meant to stay there. And it's, so in other words, you've covered it with metal and it can't be taken off. Interlockable moving guard, so is a guard interlockable? In other words, you can open a door and there's an interlock on it. And adjustable guards restricting access, so maybe you have something where you move a guard that someone can't get past. So again, it's those kind of different types of guards. How you know, it depends on the risk, what type of guard you want there, and it also depends on maintenance. If you need to get at something, you know, you need to get at it, so therefore you need to remove the guard to get at it. So that's something you have to determine. And then there are special requirements for protective devices. I mean, there can be some things. So again, you can see where you have to go through this and look at it and answer the questions that it asks you. There is specific text around all these, and we'll talk with more detail about some of them later. And then you've other hazards, and there's lots of these. There's a couple of pages of these, but electricity supply. And I mean, that would be, I suppose, if you're using an excavator, keep them back to excavators and agricultural machinery, but if you're using an excavator, you have to think of the electricity supply in your area, overhead, etc. Static, I once worked in a factory where we built up a lot of static, and static was an issue. And again, I suppose the other one then is if you're an old school milling flour, static can be a bit of an issue, but there are things where you get very dry material, so wood chip, etc., can suffer from a lot of static. If you're moving dry material over a hard surface, you can build a lot of static, so you need to deal with it. Energy supply other than electricity, well, that can be a whole lot of things: hydraulic, pneumatic, etc. Errors of fitting, extreme temperatures. You know, if your machine is either very low or very high temperatures, is that an issue? Fire, obviously, explosion, noise. You need to do something. Some machines do require noise testing under the noise directive, the outdoor noise directive. Vibrations, radiation, external radiation, laser radiation. I'm not sure there's any lasers, but emission of hazardous material and substances. So again, gases, there can be hazardous liquids, etc. So and again, there can be fumes as well. risks of being trapped in the machine, risks of slipping, tripping or falling, and lighting. So, I mean, a lot of machines would fall into that. You have to look at how you mitigate those risks. And again, you are mitigating them. It's not that they don't exist, it's just that you're trying to mitigate them, and you go through the EHSRs and you detail how you do it. For some equipment, for example, for a log splitter or something like that, very little of this would apply. Some of it will apply, but lots of things won't apply. So maintenance, machinery maintenance is very important for two purposes. A, it keeps the machine running well and things are not likely to break and fall off and hit people, etc. And also things like guards, etc. That is part of your maintenance to make sure that everything stays in place and people are doing what they're doing. Access to operating positions and service points. So the common one there, I suppose, is you should keep your operator away from any harm, but also service points, things like greasing points should not be put in a place where you can't access them. A lot of machines now have the grease points all out to one single area, so they bring the grease points out and they're piped directly to the part. So that's one. And then isolation of energy sources. Again, how do you isolate it? How do you lock out, tag out, etc.? Operator intervention. Some machines require no operator intervention. Some machines require a lot of operator intervention, and they may be intervening when the machine's still running. So you have to take that into consideration. And then cleaning of internal parts. You can't be making it impossible to clean something internally. You have to make it as easy as possible, whether that is that the whole tank slides out, the panels lift off, whatever the case is, but it has to be reasonably easy to clean. And also that depends on how often you're cleaning it and would have to be thought about. So then is your information and warning on machinery, information and information devices. So that is buzzers, lights, etc. Warning devices, again, that can be your beacons, etc. Warning of residual risk. So there can be something could tip over, you could get sprayed with water. And then there is the marking of machinery. And again, I will specifically go into that on how you mark machinery, and then instructions. So general principles for drafting instructions. So there is a way to draft instructions. Yes, there's lots of, how would you call it, flexibility in how you do that. But what you're meant to be able to do is tell your operator, your technicians, your and any other people that are using it how to use the machine safely. I suppose. And what instructions should be clear, concise, etc. And again, there's more detail later. And again, last thing it is, sales literature should not contradict instructions or contradict what you've said about the machine. So you should keep both in line with each other, and we'll go through some of these in a wee bit more detail later in the presentation. But that is the general 1.1 to 1.7, what you need to cover off. And again, with a lot of machines, you'll do that very quickly. With some other more complex machines which people have out there, it'll take you quite a bit longer to do it. So you address it as you need to. So early on, what I talked about was risk assessments. I'm going to cover off here what risk assessments are, and then I suppose what we will look at. There's a very more detailed example in the second part of the presentation. So this bit here is just a method to do risk assessments, and there are lots of them, but as long as you use something and you use it consistently is the main thing. Sorry. So the first thing is you need to define what all the things are that are involved in risk. What is a hazard? What's a danger zone? Exposed person, operator. It's all there. No point in me reading this out, but it tells you, it gives you things that you need to look at. And one of the things down at the bottom there that you need to look at is reasonably foreseeable misuse. Means the use of machinery in a way that is not intended in the instructions for use, but may result from readily predictable human behavior. At the end of the day, if you put something on a machine, if you put a step or somewhere that someone can put their foot and step up, the likelihood is they could step up and potentially they're stepping up into danger zone. So the question always is, if you put it there, you can't just say, oh, they shouldn't have used it. You have to see reasonably foreseeable misuse. Evidently, if somebody goes and gets a ladder, that's different. That's totally different. So it's reasonably foreseeable misuse. So the principles of safety integration, and this is the general overall thing. Machinery must be designed, constructed so it's fitted for its function and can be operated, adjusted and maintained without putting persons at risk. When these operations are carried out under these conditions foreseen, but also taken into reasonably foreseeable misuse. And I'll talk about that again. So the aim of the measures taken must be to eliminate any risk throughout the foreseeable lifetime of the machinery, including the phases of transport, assembly, dismantling, disabling and scrapping. And that's something that's coming in the new, it's probably more formalized in the new machinery regulation that's coming in January 2027. The life cycle, you have to think about it as the whole life cycle. So reading that statement, it's not only about operating the machine, it's adjusting, maintaining, etc. Some machines need no adjustment or maintaining when they're being used, some need lots. So again, you have to think about those. So the principles of machinery integration, you must select the most appropriate methods. The responsible person apply the following principles in the order given. So the first one is eliminate or reduce the risk as far as possible. Eliminate is always the best. An example of that is if you had a slurry tanker or if you had some sort of spreader and you had a PTO shaft and you change that to a hydraulically driven system, which is not always possible, I understand, but if you take away a PTO shaft and go to hydraulically driven system, you are taking away that transmission device. So that would be eliminate. Again, that's not always possible and doesn't have to be possible. The other one is reducing the risk would be covering the PTO shaft and instructions and keeping people away from it. Take the necessary protective measures in relation to risks that cannot be eliminated. So in other words, if you can't take away the PTO shaft, you must take protective measures, and also inform the users of residual risks due to any shortcomings of the protective measure. So nothing is ever 100% safe, so you can put a guard on it, but you also need to tell people to stay away, to not go near it, wear PPE, etc., in case something does splash out, etc. So if you have a circular saw and you're cutting plywood, there is a chance that chips and dust, etc. So you would tell them to wear a face mask and you would tell them to wear protective glasses, because things you can't totally eliminate that risk. So when designing construction machinery and drafting the instructions, the responsible person must envisage not only intended use, but also reasonably foreseeable misuse. They keep going on about this. You can't say, oh, I didn't expect them to do that. It has to be reasonably foreseeable. Complete another, stupidity you can't foresee, but you can foresee reasonable foreseeable misuse. And the machinery must be designed and constructed in such a way as to prevent abnormal use if it would endanger a risk. So, I mean, that's maybe, you could maybe put some sort of overload protective device. So in other words, if someone's trying to cut something on the machine that's not fit to cut it, that you could do that. I suppose if you think of cars, I mean, they're not CE marked, but I mean, people can put things in cars that the car won't move until you let the handbrake off or things like that. So in other words, if there's a way that you can construct it in a way that, you can eliminate that risk by not letting it start until the person does something. And where appropriate, the instructions must draw the users' attention to ways which experience has been shown might occur in which the machinery should not be used. So in other words, if you're trying to tell someone don't use this concrete mixer this way or don't use it, you should put that in the instructions. Again, within reason. All these things are within reason. So machinery must be designed and constructed to take constraints the operator is subject to as a result of necessary foreseeable use of PPE. So again, you should tell them to put it on. But again, if your operator has to wear a lot of PPE, you can't have tiny buttons on your machine. You need to take that into account for them. And if there's a specific special piece of equipment that's needed to adjust that machine or maintain that machine, you must supply it with that machine. So if there's some special nut that you have that you don't want people to adjust the machine, you have to supply the tool to do it and instruct them that it should only be done by technicians, etc. So method for risk assessment. So 1.1.2 in the ESHR says that you must carry out a risk assessment, but it doesn't give you a method. You need to go and find a method. So the very common standard that you will see out there is EN ISO, and it is an ISO standard, an international standard, 12100, General Principles for Design, Risk Assessment and Risk Reduction. It's the most common standard you would see on the Declaration of Conformity. It's a very common standard that's used. So specifies basic terminology, principles and methodology for achieving safety and design machinery. It specifies principles of risk assessment and risk reduction. It does give you lots of useful information. So for example, it tells you what height, if you're building a fence, a yard, which is a fence, it'll tell you what height to put that fence at. So it'll say 1.1 or 1.3 meters or whatever it tells you. And also it tells you then how long an arm is. So if someone can reach over that fence, it'll say that your machine should be so far from that fence. So it does give some specific general principles of guarding, etc., as well as risk reduction. So the method for risk assessment is we must identify all the hazards. That's anything which can cause potential harm. Then we must assess it and then determine what we do about it. So when you're assessing it, there's 4 areas that you assess it under. So the likelihood of the person coming into contact with it, the number of persons exposed. So for example, if this is going to be in a public area, that's very different where there is only one trained operator, or if you're operating a piece of machinery out in the middle of a field. That's very different from operating it in the middle of a town or in a playground, etc. And then how much damage would it cause? So what will it do? So in other words, if it's going to only maybe cause you a very light scratch or something, that's different from where it would remove a limb or knock you out or potentially be fatal. And then how often are you exposed to the risk? So again, you know, if it's every day, every minute, every second, that's different from being once a year. It's very different to how you would treat it. There are many models of methods of risk assessment, but there's one which I'm going to use today in a number of times during the session. That's called the preliminary hazard analysis method using the hazard rating number. You take the 4 factors and you multiply them together, and we're going to come up with a hazard rating number. So these are two of the numbers that you deal with. So likelihood of occurrence, it's impossible. Well, then it's a 0. And if we all know anything about our maths, if you multiply anything by 0, you're always going to end up with 0. So if it's impossible to happen, that's it. It doesn't matter how often it occurs if it can't occur. So then frequency exposure is infrequently, annually, monthly, weekly. There are what do you call it? These are, how would you put it? You have to determine, you know, sometimes you have an operator stand at a machine who is constantly adjusting the machine, constantly doing it. That's fine. You may have one where you only annually spread slurry, or, you know, you only monthly do something. So that is very different where you would be exposed to the risk. Then you have to think about the degree of possible harm. You know, is it a scratch or a bruise? You don't want that. Evidently, you don't want to be scratched or bruised, but at the same time, that's very different from a loss of a limb or loss. So you do have a number that you would, and again, these are all numbered. So scratch or bruise is a very low number. Fatality evidently is a very high number. And really anything, you know, you don't want any of these happening, but you have to determine what happened. Then there's a number of persons, and again, I talked about that before. You know, if it's one operator or 1 or 2 operators, that's very different to have where you have something in a public area where there's 40 or 50 people, or maybe 100 people, or people constantly walking past this. So again, you can see, you know, you put these 4 numbers together and come up with a risk. So again, this is one method. You have lots of methods out there. People use red and green and multiply all the red and greens together, etc. But this, so what this does, it multiplies the 4 numbers together and comes out with the hazard rating number. And again, then what your hazard rating number comes out at depends on what you have to do. Is it acceptable or not? So again, if that's 0, if you're down at the zeros, up to the 10, well, what's a 10? Well, that's again what you have to determine. Just because you've scored 10 and then significance says 10, So you're really determining the area that you fall into with the type of risk, and then you determine the level of risk. So again, it brings together or not, and you still have to make that decision. Is it an acceptable risk? Although you might come out with a low number, you got to say, well, even though that's a low number, we've still got to do it. So, and I mean, if I done this and Colin done this and Jackie done this, we'd all come out with different numbers, but we'd fall somewhere within those three ranges. We'd hope we'd all fall somewhere within the same range, but a different number. And any of your engineers would. So that maybe worth sometimes getting a couple of engineers to do the risks. So I'll probably run a bit early here. We're coming up to the questions time. So I don't know, Barry, if anything has come in yet. Question-wise.
Pierce, we had, I think there's just another question just in. So we did have a question just as you started this session, so it probably relates to previous section, and it says, if the storage products are then stackable and have a structural element to it, does that change the definition? So I say that was just as you were starting this second session.
So do the storage elements, was that?
So it says, if the storage products are then stackable and have a structural element to it, does that change the definition?
It doesn't change the definition of safety, but it probably doesn't change the definition of whether it requires a CE mark. So in other words, if you're talking about those containers that I talked about that don't require the CE mark, I assume that's what the person talking about.
Yeah.
Still doesn't require a CE mark. However, what it does require, it still requires to be safe. And if you're stacking them 10 high, well, then you really need to look at the bottom one, and you may need to go and get a bit of finite element analysis done on the structure. And the other thing, sorry, it comes back to something that I was talking about earlier. It's back to that thing of risk. In other words, the risk is much higher if there's another 9 stacked on top of it, as opposed to it being the top one. So what you have to look at is how these are going to be reasonably and foreseeably used. So you may want to put limits on, say, only stack 3 high. So the answer to the question is, it doesn't change that there has to be a CE mark or not on it, but it does change about how you treat the product. And if it falls under general product safety, you do need to say, look, these can only be stacked 5 high or 4 high or whatever, and they need to be structurally sound to take that extra weight.
Super. We've had another question in, Pierce, and it says, when we fabricate or assemble equipment or machinery based on customer supplied designs and drawings, are we responsible for issuing the CE declaration of conformity? So it's when we fabricate or assemble equipment machinery based on customer supplied designs and drawings, are we responsible for issuing the CE declaration of conformity?
No and yes is probably the best way to answer that. No, normally no. At the end of the day, you are still a subcontractor. Even if you're building the whole machine, you're still a subcontractor. The manufacturer is the person who is on the declaration of conformity. So even if I was a subcontractor and somebody said to me, there's a set of drawings, there's a set of hydraulic electrical drawings, will you build that product for me? You can say, yeah, I'm building it, but that does not make you the manufacturer in the eyes of, you're not the one placing it on the market. Now, they may ask you to do it, and if that's fine, you can charge them plenty of money to do it, but you treat that as you have to do your job well. In other words, that if they give you a set of drawings and there's a set of well specs and set of dimensions, you build it to that set of dimensions. If they ask you to bolt on motors, if they ask you to do the wiring, you do that all to what they have laid out for you. And by the other side of it is, you should question them and query them if you believe that something's not right. So in other words, structurally, if you don't believe that's structurally not right, you should say to them. But when it comes to the end, you know, and you can say this to them on the invoice or whatever, but you are not responsible for CE marking that machine, because you're not placing it on the market, and they can't say that you're responsible because they haven't instructed you to do it. It's a bit of a gray area. People could go back and say, oh, but you built it, you done it. You should probably make that clear if you're doing that sort of stuff. So if you're just building a sub-assembly, you're responsible for the sub-assembly. If you're wiring it, you're responsible for wiring it. But at the end of the day, the person that places it on the market is ultimately responsible, and they are deemed the manufacturer. So the answer is no, you're not responsible, but you do have responsibilities, I suppose, and you should be clear with your customer as to what you are and aren't going to do for them. hopefully that answers that.
That's great. Yeah, that's the only couple of questions we've had in so far. We do have further opportunities as we go through, but I'm sure you probably are ready for a break, Pierce. You've done a lot of talking, so do you want to go straight into the break now?
I think we will. We'll take the break early, and then, as I say, hopefully maybe it gives us more time. The afternoon can maybe overrun a wee bit, so we're better to take that break a bit earlier. And then, as I say, I don't know, you tell us what time. It's 10:41 now, so what time do you want us back for, Barry?
10:41. It's just I'm going to say it's now. When we say 11 o'clock, we give sort of 18-ish minutes or so. So we say bang on 11, just keeps it nice and round.
Right. That's okay. We'll start back at 11 o'clock. That's great. And if anybody has any questions in the meantime, feel free to submit them.
Absolutely. Keep firing them through, and I'll keep track of them all.
Brilliant. Okay. See you at 11.
Thanks, Pierce. Okay, folks, just coming up on 11 o'clock. So just do a check in, see if Pierce is back in the game. He is. Correct.
Yep.
You should still have control of the slides. Pierce, I didn't take them off you, so with any luck, if you just click on the, that's you got control now. Okay, whenever you're ready.
Okay, right. Okay, I'm just going to finish off answering that last question. By the way, just one wee thing I meant to add to that last query that the person had was that they said, could they CE mark the product if somebody else asked them to make it for them? And probably the biggest answer to that is no, because you don't know everything. You don't know, you may build the machine, you may do this, you don't know where it's used, you don't know about all the components. So you need, and part of today's thing is you need all the knowledge to fully CE mark machine. You need everything to know about everything that goes into it, where it's going to be used, risk assessments, etc. So we'll move on. So we're going through a lot of theory stuff here, and as I say, later on in the presentation, I'll probably try and bring that a wee bit more practically to life. But we do have to go through all these bits that are in the technical file, and I'm going to continue to explain all the aspects that are in the technical file and the things that are relevant to it. So one of the areas then, and one of the things you use to show compliance is, so you comply to directives and regulations based on harmonized standards. So you use standards to do that. And the United Kingdom is a member of CEN and CENELEC and ISO. So these are how standards are created. You'll see at the start of standards, you will see names. You'll see that they have a title and a descriptor and a number, and these are developed by CEN and CENELEC. So CEN is the European Committee for Standardization, and CENELEC is the European Committee for Electrotechnic Standardization. These are associations that bring together national standard bodies of 34 European countries. ISO is the international standard, which is developed probably more than that number now, 25336. International standards apply across the 171 member countries, so it's much broader. And so each BSI is the UK's national standardization body. It's a one-stop shop for all the stakeholders, and it's the main focal point of access for the concerted system, which comprises regional, European and international standards. So we'll say each country has a designated body which brings the standards, and their job is, as I said at the end, the national standardization body distributes, sell the implemented international and European standards, and they have to withdraw any conflicting national standards. It's the responsibility of CEN and ISO national members to implement international European standards as national standards. So this is they're BSI for the UK, IE for ROI, DIN for Germany, and there's a whole lot more. So that's who you can go buy your standards off. So there's a whole lot goes on in the background around standards in draft form being developed, etc. But as I say, they are meant to take the old ones off the market. And by the way, it has nothing to do with the European, well, it's not that it's nothing to do with the European Union. When they talk about regional, the UK is still a member of CEN and CENELEC, as in it feeds into it and it takes standards from it. So standards, Machinery manufactured in conformity with EN harmonised standards are best practice and shall provide a presumption of compliance to the ESHRs. Harmonised standards provide technical specifications and ensure machinery manufacturers to comply with the EHSRs. They are guidance documents, but they're more specific. So standard will give you ballpark guidance, or sometimes not even that specific guidance, where standards give you specific guidance. How big is something? How wide is something? How much load should it hold? Since harmonised standards are developed and adopted on the basis of a consensus between the interested parties, their specifications provide a good indication of the state of the art at the time they're adopted. They do take a while to catch up, and that's why you will see amendments to them, to see the A at the end of the number where they'll amend something. Some of them, to be fair, are old as the hills. A lot of the mechanical calculation ones, the mechanical calculations still stand from way back when. The number might be updated, but you'll see that the calculations still stand. The evolution of state of the art is reflected in later amendments or revisions of harmonised standards. So things do move. They move particularly fast in the world of electronics. They don't move as fast in the world of mechanical standards. So your control standards will change, but your mechanical standard will not change as fast. There are three basic types of standards. There's the A type, which is applied to everything, or you can use for everything. There's a B type, which promotes safety, so standards particular safety, which is noise, safety, distances, temperatures. And B2s are then standards on safeguards, access control, control system, guard, interlocking devices. And then C type is specific to a machine. If you have a C type standard, first of all, you should be using it. And secondly, it's a good thing because it will tell you lots of information about how you should build your machine and what should be on and what should not be on your machine. So C type standards are a very good thing if you have one. Just a few examples. I used the example earlier of the 12100. That's a general principles for machinery. It's a very, very broad standard. You'd see it on lots of declarations of conformity. But it can be overridden, not overridden, but I mean, there are C-type standards. So for example, the agricultural machinery part 1, 4254 is specific guidance around agricultural machinery general requirements. So it'll tell you things about 3-point linkages. It'll tell you things that to do with agricultural machinery. The B's then are things like if your hydraulic fluid, your pneumatic fluid, your safety of machinery guard. So it's generic type stuff which promotes safety. They're always to do with safety and control systems. And then your C's. So I suppose I always get a bit of stick for this. It's kind of an agricultural based seminar in some ways, but you know, we talk about the safety. They're very specific parts. So you have your 4254 part 1, which is general, and then 425 part 6 is, I talk about this later, I'll use this one later, liquid fertilizer distributors. 707 then is slurry tankers. 619 is a continuous handling equipment for safety requirements for equipment for mechanical design, handling of unit loads. And then trailers, I talked about the tipping trailer has a very specific standard. And as you can see, the AC 2019 means that was updated in 2019. And sometimes these standards, I have to keep checking these because they can change completely. And numbers can change also too, but generally the numbers stay the same. So that is a broad overview of standards. You are required, if you quote a standard, use a standard, and it's on your declaration of conformity, you're meant to keep the up-to-date copy, and that's part of your ongoing, how would you call it, manufacturing processes. You're meant to, every 6 months, every year, check the standards. You sign up to BSI, you sign up to NASI in the South, whatever, and if you have bought that standard, then you will get a notification of updates. They don't happen very quick. You get a notification sometimes a couple of years in advance if something's going to update, but when it updates, you're meant to keep the updated version and then update your product, update your technical file. Procedures should be put in place to review standards and then and to update any changes. So you should keep some sort of procedure to say, we've annually reviewed it, there was no changes, or we annually reviewed it, there was an amendment, and we've implemented the amendment, and you should document that. If you read a standard and there's an Annex ZA, it will generally state the EU directive that, so it can be used to prove conformance to. So if you read the slurry tanker standard, it will quote the machinery directive in Annex ZA and say you must comply to this. And it may quote another couple and say you may fall under pressure directive, you may fall under, but it'll, so always go to Annex ZA or ZB in the standard and see does it apply with your, apply to your machine. That standards, I'll show later on in my worked example when talk through how to actually use a standard then to actually show compliance. I will give a specific example of it. It's agricultural based again, as always, but there is a specific example there. So technical reports and certifications is another section. So we're moving on to the next section of the technical file. So if you have any technical reports given the results of tests carried out either by the manufacturer, industry expert, or a body chosen by the manufacturer or his authorized representative. So if you have any kind of test reports, you can put them all in here. It's just good to locate them together. Some of them may be a notified body report. You may go to a TUV or an Intertek or somebody and get some specific part of your machine done. Or if you went to a consultant engineer and he done a finite element analysis report, keep it in here. Also, if you do get some EMC testing, if you got noise testing done on your machine or any kind of third-party accreditation, just to keep together any reports that I suppose aren't done internally by the company. Keep together anything that's there. If you had a test certificate for a power pack, a hydraulic power pack you're using, it may be a generic test certificate that the company does. They may not test everyone, or maybe they do test everyone. You can keep a copy of those, or even a sample copy of those in your report, in your technical file, sorry. So then we're moving on to instructions for machinery. So this is about how you actually put together instructions for machinery, apologies. So all machinery must be accompanied by instructions in the official community language or languages of the member state in which it is placed on the market and or put into service. So if you sell a machine to Italy, you should send an Italian set of instructions with it, and you also should send your original English version of instructions with it. We're lucky because we are one of the three languages, the three community languages, which official community language, which is English, French, and German. But also, if it's going to Italian, Italy, or whatever, it has to be sent in it. The instructions accompanying the machine must either be original instructions or translation of original instructions, in which case translations must be copied by the original. So you send it to Italy, send your original English and send your translated, and make sure it's known to be a translated version. Now, a lot of people say to me, well, nobody's ever asked, nobody's ever thing. That's what it says in the machinery directive, that you should send it. Luckily, a lot of our European counterparts speak English, so they sometimes don't request it and are quite content with it, but they can request it and should be getting it. So there is guidance on contents of instructions, and so first place you find guidance is in the machinery directive itself in section 1.7.4.2 of the AHHRs, which is quite generic. Then if you have a C-type standard, it will give you more specific. So for example, if it was back to your slurry tanker, it will give examples of how you should load, how you should unload, things like that that you should do for slurry tanker, and other machinery that has that specific C-type standard. Instructions should be clear and concise. There's nothing worse than instructions that go on and on and on, because at the end of the day, the user doesn't read them, they don't understand them, and they give up before they get to the point that you're really trying to tell them. So be concise, less is more. Pictorials and photographs should be used to reduce long passages of text. I totally agree with this, and I'm sure you all do. If you are showing somebody how to hook up a machine, or if you're showing somebody how to load a machine, you can do it maybe with 4 or 5 photographs, and you can show them pictorially how to do it. The types of instructions you should then send should be the assembly instructions if they are required. Some don't require it, some do require it. Operational certainly has to be there, so how it operates, and maintenance instructions. So the maintenance instructions are things like your daily, your hourly, your daily, your monthly, your 6 monthly, and your annual inspections. You should tell them what you expect, how you expect them to maintain the machine, And again, if there's any special instructions around maintenance, any gaps you need to set or something like that there, you need to do that as well. And again, if there's a wear part in your machine, you should give guidance in the maintenance instructions as to what the limits of that wear part are. So for example, coupling a tow eye on a trailer or a tanker, if you said that it comes and it's 55 mil thick, and at 52 mil thick, you should change it. You should put those specific instructions into your maintenance manual and say that if this measures below 52 millimeters or whatever the instruction is, you change it out. And there's lots of wear parts and lots of machines, so you should tell them what to do. And you should be concise and pictorially potentially tell them what to do. So again, the instructions must specify the adjustment and maintenance operations that must be carried out and indicate their frequency. So do you clean it every day? Do you clean it every 6 weeks? Do you adjust it every day? Do you never adjust it? Only a technician adjusts it. The instructions must list the elements or parts of the machinery that must be regularly checked in order to detect excessive wear. I've just spoke about that. The periodicity of these checks in terms of duration or number of cycles, that's another thing. It's a bit like an oil change. Do you change it annually or do you change it at a number of particular cycles? Or the other thing is we're getting a lot of maintenance now, which is condition-based maintenance. So in other words, you change it when the oil gets to a certain viscosity, or you change it when the part wears to. So condition-based maintenance as well as periodic-based. So you need to say when they should change that. So a lot of things like engines that say change the oil at 5,000 hours or whatever. So stuff like that. Wheel nuts, you might say yes, tighten them to a torque setting, but then you might say within 10 miles retorque them. So things like that you need to put in. The instructions must specify the necessary methods and procedures to be followed in order to ensure the adjustment maintenance can be carried out safely. Do you need to lift something up? Do you need to remove a guard? Do you need to do whatever? And the appropriate protective measures and precautions to be taken during maintenance operations should be indicated. So again, do you need to wear PPE? Do you need to prop something? Do you need to move something? That all should be indicated in your instruction manual, whatever you need to do. Do you need to take it completely off the machine? Do you need to send it out for refurbishment? That could be in there too. So that's how you write a set of instructions. That's very different for very different machines. If you had a log splitter, you'd write that all on one page. If you had a excavator, it could be 30-40 pages. It depends what it is. So as I say, it's very broad, but it should be clear, concise, and it should be able to tell the operator and user how to keep the machine functioning. So the next section in the technical file then is supplementary information. So things like copies of EC declarations of conformity of machinery or other products incorporated into your machine. So declaration of incorporation should be in there. Declaration of conformities, because some things are standalone machine which you will incorporate in. So any of those kind of conformity documents that come from your suppliers. Copies of instructions from machine or component suppliers. So if your pump supplier, gearbox supplier sends a set of instructions, you keep a copy of that. You may also wish to send that on with the machine, which is fine, but you should have a generic copy as well in your technical file. And then any other information from your supply chain that is necessary to prove compliance to the machinery directive. So in other words, if there's something else, that some other piece of supplementary information that I'm not mentioning here but is specific to your product, you should keep copies of that. Again, this is your technical file, you keep it. Does not necessarily go to your customer. In fact, it probably won't, apart from copies of manuals and stuff like that. So we're going to eventually get to the CE mark, but we're not quite there yet. So declarations and marks. So the machinery directive will require either a declaration of conformity or a declaration of incorporation for partly completed machinery. There are other declaration certificates that do not relate to machinery. So if you get a machine and it's got a certificate of conformity or a declaration of performance or a certificate of performance, I've seen all sorts of things. That is not what should come with a machine. A machine should come with a declaration of conformity or a declaration of incorporation. A trailer may come with both. So a trailer could come with, so a tipping trailer could come with a certificate of conformity, but it also should come with a separate declaration of conformity relating to the machinery parts. Construction products come with declaration of performance, so that's your roller shutter door, but again, your roller shutter door would come with both. It would come with the declaration of conformity and declaration of performance. And there are other directives, have other declarations and stuff, but those are kind of the common ones you'd see around machinery. But certainly the top two come with the machine. So declaration of conformity must be drawn up by the manufacturer of the machinery or his authorised representative in the EU, and that must accompany the machine until it reaches the end user. We'll talk about it later, but those are going to go digital in the new machinery regulations. But for now, you have to send a paper copy. Talks about your authorised representative. If you were not in the European Union, so in other words, if you're manufacturing these outside of the EU and you're buying a machine from outside of the EU, the declaration of conformity should have an EU address on it. If it's not the manufacturer, the authorised representative should be based in the European Union, and that should be on that declaration of conformity. If it comes from India, China, wherever outside of the EU or EEA, it's not on it, well, you should be asking questions. The EC declaration of conformity is a legal statement by the manufacturer or the authorised representative attesting to the machinery concern that the machinery concern complies with all the relevant provisions of the machinery directive. So what you're saying, again, it's that kind of thing. It's back to, it's a promise. And Simon talked about this. If any of you were at the electrical seminar last week, Simon talked about this, about CE marking and how it is really, you are making a statement, and then as an end user, if you're buying it, you have to either decide whether you believe that statement or not. So how do you create a declaration of conformity? Well, these are the things that must be on it, and this is out of the directive. This is what it says: business name and full address of the manufacturer where appropriate, his authorised representative. So in Northern Ireland, your address stops at Northern Ireland. It's not Northern Ireland, United Kingdom, it's Northern Ireland, because Northern Ireland is, for the purposes of CE marking, is where you're allowed to create a declaration of conformity. So you stop with your address as Northern Ireland. Name and address of the person authorised to compile the technical file who must be established in the community. So that's what I was saying before. You can have the name and address of manufacturer in China, in the US, whatever, but there should then be a name of the technical file should be compiled by a person in the community, in the European EEA, I suppose, is the broader community they're talking about. Description and identity of machinery. It needs to say what it is. If it's a slurry tanker, it needs to say slurry tanker, and then model, type, serial number, and commercial name. So if yours is the, whatever the commercial, and if it carries like a trademark name, that should be on there too. And it should say like slurry tanker, 10-ton, single axle, something like that. Or it could be, you could have a couple of, you could say that this covers, the 10-ton, the 20-ton, the 15-ton. You can have a number of different models that covered by one declaration of conformity if they're all basically the same machine. And then you put the sentence expressly declaring that the machinery fulfills the relevant provisions of the directive, and where appropriate, a similar sentence declaring the conformity with other directives and or other provisions which the machinery complies. So in other words, low voltage may be on there, outdoor noise may be on there, and those directives should be on there. Where appropriate name, address, and identification of the notified body. So if you did use a notified body, not just for testing part of the machine, but in other words, this is if they are standing over the whole overall machine, they've done their notified body for the whole machinery directive, they would be on it. But you don't generally see that with machinery. You see it with construction products, but you don't see it with machinery. And where appropriate, the name and address of the notified body which approved the full quality assurance system. So again, if that's appropriate, you put it on. Where appropriate, a reference to the harmonized standards used. Again, I'll show you a sample in a minute. So if you're using EN 12100, you note that standard on it. And then the place and date of declaration. So, and the identity and signature. So there should be a copy of the person signing it. the person that signs that should not be the cleaner, shouldn't be the junior engineer in the office, unless for some unknown reason it's generally the managing director of the company. It can be a senior technical person in a bigger company, but you'd always question why a managing director is not signing the declaration form. At the end of the day, they tell their engineers, etc. But yes, senior technical officer or whatever, he or she could sign that as well. But it's not a junior engineer signs this. So I've given a couple of examples there. I mean, I've just mocked these up. EC declaration conformity, declaration number. The reason I sometimes would tell people to put that on, if you have multiple declarations, at least you can track them. You say to people, what's the number at the top of that declaration? I'll check it for you. You may or may not. It's not a legal requirement that it's only for your own internal reference. And then we, the undersigned, blah, blah, blah. And as I was saying, it's your country is Northern Ireland. Declare under our sole responsibility that the following machines. Now you can have more than one machine, so agricultural tipping trailer, so 12 ton, 14 ton, 20 ton, if there's no brand name in these, is in conformity with the following EU legislation, machinery directive, based on the following harmonised standards. So I've used the general safety requirements for machinery, for agricultural machinery. There's a trailer one, and then there's hydraulic fluid. In fairness, I probably should have the 12100 on there as well, and I'll change that for next year. But yes, so you have a list of harmonized standards. It's up to you how you list them. You don't list every one. I've seen some with like 12, 14 listed. They're not real. I mean, someone listed once on. There is a standard on how you create a CE mark. You don't need to put that on. It's the standards that you actually use, because by the way, if they're on this, they should be in your possession. You should own them, and you should own the most up-to-date version. And then you say, and therefore complies with the essential requirements of those directives. You can give the technical file a number and a location if you want, but you do have to state the location of the technical file. So it's normally as above, as in the address, and name and position of the person binding the manufacturer or authorized representative. So again, normally owner, MD, location, HQ or address if you want to put on it, date of issue, and the actual signature. As you see, I've left the space there for signature. So the other one on the right hand side is for a slurry tanker. Again, it's something very similar, model numbers, different standards, as you can see. So you need to keep the appropriate standards on your thing. And then, as I say, the rest is pretty much the same. So you'll have machinery directive on all of these, and you'll have different standards on them. It's very rare you would see no standards. The 12100 would be in almost every one. So again, that's how you construct a declaration conformity. And I mean, if we just step back a wee second to that, those things are meant to be on it. And if you go to the ones that I've done, those items that are all listed out there are on it. So you can construct it how you want. There's no actual CE mark on a declaration conformity, and you shouldn't be putting big bright logos. You shouldn't be distracting from the legal document. It should just be that plain one-pager document with the information on it. Declaration of incorporation, although of quite a bit of detail here, I'm not going to dwell too much on it. It is different, and it is actually harder to create it. People say, oh, I'll do a declaration of incorporation, and I'd say, well, good luck with that. I'd be trying to do, unless it is actually requiring a declaration of incorporation, a declaration of conformity is much easier to draft up. Reason being is a lot of it is the same, but then number 4 is a sentence declaring the essential requirements of the directive that are applied. So you have to go through all of the directive. You have to note every one of the essential requirements, as in 1.1, 0.6, 0.7, 0.8. You have to note them all out in the list. And then you take an undertaking to transmit response request by national authorities, the relevant information on the partly completed machinery, the method of transmission, and then without prejudice to email. So it's a more complex document. It's longer. It's hard to get on one page. Some people do need to do them, and that's fair enough. If you need to do it, you need to do it. This is how you draw it up. I haven't actually given an example of one. If anybody needs one, I think I have a template of one there somewhere. So as I was saying, I have quite a number of slides in here in this presentation, whatever I have at this stage, 146 or whatever. The next two are the only ones that relate actually to the CE mark. So everybody says, oh, I've got a CE mark on it, it's grand. So when you create the plate that you put on your machine, so you're meant to give the company, your end user, your machine, and you're meant to mark that machine. All machinery must be visibly, legibly, and indelibly marked visibly, legibly, indelibly with the following minimum particulars. Now, indelibly means it can't come off easily. Most of them are a metal plate, although there are some good stickers now which don't come off. But if this is going to be power hosed, if this is going to be, that sticker needs to stay there. Sorry, that plate needs to stay there. You know, I've seen old diggers or old tractors which are made in the 60s, and the metal plate is still on them. You know, it's indelibly marked. So what you need on it is the business name and address and the manufacturer and an authorized representative if that's applicable. Designation of machinery, say what it is. Is it a slurry tanker? Is it, you know, what is it? Is it a crusher? Is it a screener? Is it a log splitter? Designation of machinery, you need to say what it is. The actual CE mark is on it, and then the designation of series or type. So if it's a log splitter, it could be a 10 ton, a 12 ton, and it could be engine driven, it could be PTO driven, it could be hydraulically driven, 3-point linkage mounted. So those kind of, without again War and Peace, your plate is meant to be simple. Plates can get overcomplicated, don't overcomplicate them. Put a second plate on if you need to put lots of information on. Then the serial number should also be on it. And the year of construction as a minimum. Some people put the date of construction, which is fine, but the year of construction is the minimum you need to put on it. And it is prohibited to predate or post-date machinery when affixing the CE mark. So when the new machinery regulation is coming in 2027 in January, and everybody starts to print a load of plates and start to put out 50 machines all in January, where they normally only put out 100 in a year, it would raise questions. So, and then you put the CE mark. And as well, I have seen this done wrong. The CE mark has a very specific text, font, spacing that you can go and download it free off a lot of the European Commission websites. You can actually download it, but I have seen this done wrong, and not just by the Chinese or whatever. I've seen it done wrong by manufacturers. You're meant to do it correctly, and there's a very specific shape, etc. to it. So that is the CE mark in 2 slides as we talk about. But yes, there are very specific things. Now, some people do put other CE marks on machinery in other places. I'm not totally sure why they do that, but that's up to them. And I've went to shows, and I'm sure we've all been to shows and stuff, and you have big CE stickers on machines. Not quite sure what the purpose of it is, but people do it, so that's fair enough. So then next section in your technical file is the manufacturing processes. So in other words, you are meant to be able to create serial number 1, serial number 101, and serial number 1001, and all in between and after. You're meant to be able to create them the same. So for series manufacture, which most of us at the end of the day are doing, or most of you are doing, you're building more than one of these. So document internal measures, which will be implemented to ensure that the machinery remains within conformity with the provisions of this directive. So in other words, you're meant to say, you know, this machine, if this is the 10-ton machine, you're meant to have 65mm pins as opposed to 43mm pins. You know, you're meant to control how that machine is built and goes out the door. And the other thing as well is, and we'll talk about in a minute, is change. If the standard gets updated, if something gets updated, you're meant to have some sort of way of internal change control. So evidence to ensure the quality control and repeatability. Your main one is your job card or your build sheet or whatever you would call that. You send it out and you send it out onto the factory floor. You have a job card that goes with it. You tell the operators which pins go in it, what size goes in it, which options this customer has ordered. All that goes onto it. You then control that internally, so there shouldn't be the wrong drawings, the wrong documents. And I know a lot of manufacturers in Northern Ireland are moving to touch screens out on the floor, etc. So they're going paperless, which is a great thing, I think. You do not need a formal ISO 9001. You do need some sort of quality system. You need to control your quality, but the machinery directive doesn't require you to have ISO 9001. It's nice if you have, but at the end of the day, you can control it internally. So what this is saying is, if in your technical file, samples of job cards, build sheets, all that, internal change control for drawings, if you have a procedure for that, etc. If you're a small company, you may not have a lot in this file, in this section, but you should have something to control all that. So anything that you feel you need to control, and again, your standard review would be linked to this as well. So what I've done is, I actually added this in recently this year, is you've got your technical file, so you need to structure that in some way. I was back to the old tabs, you know, which we had before when it was all paper-based, but I suppose we're going digital now. So this is one way that you could do it. So you may have a Word document, you may have an Excel document, you may have other documents, some sort of, you know, whatever software is available. So if I opened that up, if I was a new engineer, or if I was the quality engineer, or if I was the person responsible, I would have this 1 or 2 page or 3 page, whatever it would be, document. This is the technical file for the slurry dribble bar. You'd have for the user. So you have to think of people that are reading this that are kind of new to it. If somebody come in to inspect you, this needs to make sense. So you would have a quick description of it, maybe a picture of it. You'd say what models this technical file covers. So it covers 6, 10, 12 meters for 3-point linkage, and the tanker version. It also covers the front reeler and the rear reeler, which is fine. I mean, it's all related, so you want to keep it all in the technical file. You may issue separate declaration of conformity. So the first thing you'd add in links to your sale brochures. You're going to store them somewhere in an internal server. Then you would have your, just the way we talked through it there, drawings, all your detailed drawings, assembly drawings, section views, whatever you want to do, bill of materials, click on the link, and then that is quickly brings the person to that wants to see that. Manuals, you'd have your assembly instructions, your operator instructions, your technical manuals, your maintenance manuals, troubleshooting guides. You can quickly click in. You may then, when you click into that, you may have, you know, you may have it for different sizes, etc., which is fine again. So you could have a number of sets of instructions. Wiring diagrams, part list, again, you can see there, electric, pneumatic parts list. Click on them, take you straight to it. Harmonized standards, you will store those electronically as PDFs. If someone once says, show me your 12100, you click on it, that'll bring you to the version that you store internally. Risk assessments, again, you might want to break that down into the risk assessments in different areas. So you might have it for different sections of the machine. You might have the different risk assessments for that. So you might have all those. Then again, your essential health and safety report. Again, you may want to go and have it broke down into your areas that you click and you go to it. Design calculations, again, the same. You might have, as I say there, you might have FEA calcs, you might have some weight calcs, you might have FEA done on the tanker brackets, whatever. Copies of test reports, again, there might be a specific report that you're alluding to. You know, I put a date on there. You might have where you've done a multi-cycle report on your full unfold. Sporting documentation for those, there might be, if you're buying in a macerator, if you're buying in a pump, those documents there. So again, sample for the manufacturing process, sample of the build schedule, sample of the build schedule for the reelers, the dribble bars, product modification process, change control records and procedures. And then let's say, I'm using an example here, if you had a specific recall from your RAM manufacturer or something, you could say there's the June 2023 RAM recall modification. You quickly click to it, you know it's there, it was very relevant at the time, so you have it. And then a copy of your declaration of conformities. So that is one way to just keep a high level structure of a technical file, because at the end of the day, we're all going digital. Most of your documents are digital. Even if you bring something in, you get a digital version from the person you get in, or you scan it, you put it away. So that's just an idea of how you might do it. There's lots of ways you can do it. You don't need to do it like that. You can do it whatever way you want. So that is the contents of a technical file gone through probably at some speed. But again, with a lot of this, as Barry said earlier, you will be getting a copy of the slides. You can take your time and go back through this and either listen to me talk about it or take your own time and go through it. So that's me up to that section. Jackie is going to do a bit of talking after this set of questions. But for now, we can see, Barry, do you have any questions in for us?
We do not, Pierce. So again, feel free to submit questions, but you seem to be covering everything in enough detail where no one has any questions as yet. So wait, I tell a lie. There we go. Question just in. So does Invest Northern Ireland have a Word template for the technical folder that you could share? Is there a template, Pierce?
Yeah, I have a couple of, so I have Word templates. Again, use them at your own risk, but I have a Word document which gives you a couple of templates for declaration conformities. Again, I can't stress this enough, you need to tailor them so you cover your legal requirements, but basically, yes, the text is there for declaration conformities. I've mocked up a few for things like log splitters, trailers, machines, and also in that, yes, there is a template, not this template that I just covered because I don't have that, it doesn't exist, but I have a template for the list of contents. So yes, it can be done, and if you want to email me directly, or if you can't find my email address, tau@InvestNI, we'll certainly get that sent out to you. Or by the way, if you are a InvestNI client company, you can come through your client executive or our business support team. If you dial our 0800 number, or I'm sounding like one of those where I'm selling something here, don't I? But if you contact
terms and conditions apply.
Exactly, and there are other enterprise agencies available, but not in Northern Ireland. No, if you click on the website and click on the chat boxes or contact our business support team, either ask to speak to me or just put in what you've just asked, certainly we can get out to you. So yes, the short answer to that very long answer is yes, it does exist. If you want it, I'm happy to share it.
Okay, I've got another slightly longer question in. So if you have a machine with its own PLC control and safety circuit covered locally, but it is intended to be incorporated into a parent machine in order to supply power, supply input signals in order to tell the machine what to do, and then fully enclose any hazards that would otherwise be exposed, would it be CE marked or would it require declaration of incorporation? So what I'm going to do is I'm actually going to pop that question into the chat for you, Pierce, as well, because it was quite a long one.
Yeah, this is a question comes up all the time. There's no, I suppose there's no wrong answer to it, because at the end of the day, what we're talking about here is a different document that you send it out with. You either send it out with a declaration of incorporation or declaration of conformity, and you either put just a wee CE mark on it or not. That's the only difference. You do everything else the same. You do your risk assessment, you do all that. So the answer probably is, if that machine can be used standalone, if there's a plug on it where you can plug it into 240 or 415 and it will fire up and function on its own with a touch screen. One of the examples would be maybe an overband separator, some magnetic separator. You can plug those in and press the start button and they go, but then lots of people do incorporate them in, and the signal to start that will come from a central control panel. So I don't know enough about the machine, but I suspect what you're talking about there is a declaration of conformity. It is a machine that stands alone. If it's not, declaration of incorporation, as I said before, is more difficult and more time consuming, because you have to give that end user the information so they can incorporate their machine in, and then they CE mark the whole thing. So if you give it to them, whichever way you give it to them, the end user has to CE mark the overall system, and they have to incorporate it in, because if their parent machine is controlling your machine, so in other words, that power signal is coming from their parent machine, they're taking control, but by the same token, your machine should do what they expect it to do. So if your machine has a light barrier on it, and you trigger the light barrier, it should stop it and potentially part of the other machine. So you do everything bar the document. So if you could plug that machine in and there's a control panel on it, even if it's start stop buttons, it's declaration of conformity. If there's no control panel and you plug it in, or maybe you can't plug it in and it can do nothing, it's declaration of incorporation. But back to my point, you do everything else. You do the whole technical file yourself, you do all that. So yeah, I think if it can function, if it can plug in and it's got buttons or touchscreen or something that it can function on its own, it's a machine declaration of conformity. I'm confusing myself here. But if it can't, if it literally has got no way to control it, it's declaration of incorporation. And that, unfortunately, for yourselves is a more difficult piece to carry out. So hopefully that answers it.
Brilliant. So no other questions in at the moment, but there is an opportunity at the end again to answer questions. So I think, Pierce, I might give you a bit of a break to catch your breath. What I'm going to do is I'm going to take slide control off you and I'll bring up Jackie's slides. So just give me 1 second and then we'll hand over to Jackie.
Okay.
Okay, Jackie, it's over to you.
Great. Thanks, Barry. So I'm going to just cover some best practices for conducting an annual review of your CE marking technical file. So it is essential to keep this document up to date, not only to ensure compliance with the relevant standards and directives, but also to accurately document any changes that have been made to your product. So I guess first off, it's the document itself. So as Pierce touched on earlier, it is important to have a clear document structure. So good idea to structure it logically, breaking it down into clear sections. So, as Pierce went through, the product description, risk assessments, test reports, standards. And this just makes it easier to locate and update the information as and when you need to update it. The versioning control system, again, you should implement a clear version control system for the technical file so that each update is uniquely identified. This allows just for easy tracking of changes over time and ensures, I guess, most importantly, that the latest version is used. And this kind of would also help, I guess, to streamline future audits and inspections of the document by having this in place. Changelog, you should maintain a comprehensive changelog that details the nature of each modification. So this, would also include the date of the update, the person who is responsible for the changes, and by having this, it just enhances transparency and accountability. Then on the digital accessibility, so it's a good idea to have the file stored digitally, and it just ensures that it's easily updated and accessible if requested by a regulatory authority. So for digital storage, it is advisable to use, backup solutions to prevent data loss, but also unauthorized access. So when you're doing your review, it is a good idea to collaborate with different teams. So if you look internally, you could engage with, R&D, quality, production, and this just allows for each team to provide insights on different aspects like design changes, testing, regulatory compliance, and it is a good idea maybe to assign a responsible person or a team for the file management, just to ensure that no crucial information is missed. Then if you look externally, you should get input from your supplier and subcontractors. So if any changes have been made in materials or components from the suppliers, you should obtain, the necessary documentation from them. So that could be, declarations of conformity, testing data, and these updated documents should be in your technical file. And I guess this is especially important if new materials, they might affect compliance in standards like RoHS, REACH, or other specific product safety standards. So then documenting your design changes and modifications. So technical design changes, you should document any changes that have been made to the product. These could include obviously design changes, but also materials, components, or manufacturing processes. And you should evaluate whether these changes impact the CE conformity. You may have to conduct necessary testing. So if significant modifications have been made, you may need to perform additional testing to demonstrate ongoing compliance. And you should update the technical file with any new test reports or performance data. Then onto your technical drawings and documentation. So your technical drawings, you should confirm that they're accurate and reflect the current design. You know, make sure your revision history tables are updated and that you're using a consistent revision numbering or naming convention. So, you know, Rev A, Rev B, version 1, version 2, and this is just to avoid confusion. So also, with your drawings, you should ensure that previous versions are archived in case you ever need to reference them later on. Review your BOM or your bill of materials. So make sure it's current and includes all components used in the product. And you should also remove any obsolete components. Then with your wiring diagrams and schematics, make sure they're all, you know, up to date and reflect the current product setup. Again, you should maintain a detailed revision history for all diagrams and schematics. And, you know, by doing this, it's crucial for traceability in case of audits or, you know, potential product recalls. So then onto the regulatory and standard changes. So you should check for changes in your directives or regulations. Changes, I guess, to directives don't happen very often, but it is still best practice to check if there's any updates or amendments that have been made, just to ensure ongoing compliance. With your harmonized standards, these can update more often than the directives. So you should verify that the standards referenced in your technical file are still valid. If no updates or changes have been made, you should confirm your product and documentation align with them. And you should verify if any significant updates in any of the guidance documents that they may affect your product CE marking. Onto risk assessments. So you should reassess potential risks that could be associated with the product. So especially if new risks have emerged from, you know, customer feedback or incidents that may have happened over the year, and ensure the existing risk assessment reflects the most recent data and analysis methods. Then you should update your mitigation. So if any new risks have been identified, you should document any additional mitigations or safeguards in the technical file. On your supporting documentation, so labeling, you should confirm that the labeling complies with the current requirements. So this could include, you know, affixing the actual CE mark, providing any necessary safety symbols, and also, you know, update any manufacturer details. So if you've moved premises in the last year, for example, just make sure that all of that has been updated. On your instructions for use, ensure your user manuals and instructions for use are accurate and comprehensive. These should be updated to reflect any new warnings or instructions. You know, as Pierce mentioned earlier, all machinery must be accompanied by instructions or manuals in the language of the member state in which it's being used or put into service. So if your product is now being sold into a new EU country, you may need to get that translated. Then on the declaration of conformity, just make sure your DOC is still valid, reflects the current status of the product, and just make sure it references the correct directives and relevant harmonized standards. We don't seem to want to move page there, Barry. There we go. So on the internal and external audit, so it is a good idea to consider conducting internal audits of the technical file to ensure that it is fully compliant. So this would just help to identify any gaps, outdated information, or areas that might need improving. And then by preparing for notified body inspection, so if your machinery requires, or your product requires third-party assessment or certification, you should prepare for any potential inspections by notified body. So by designing your technical file to be audit ready at any time, it's just ensuring that all documentation is in order for a potential audit or an inspection. You should also consider international compliance. So if your product is being sold outside the EU, you should ensure compliance with local regulations. So really ensure that any updates to your CE mark and technical file align with the documentation that is required for other relevant certifications. So like for the UKCA for the GB market, looking there, you've got the FDA or UL for USA, excuse me, you've the RCM mark for Australia and New Zealand. So really it's just keep your documentation updated and consistent across different regulatory systems and be aware of any specific requirements. We will be discussing international compliance in our next upcoming webinar. Again, it will be another half-day session and you can register for this on the InvestNI website.
That should be you now with control. Sorry, I took it off you again momentarily. That's you again. Okay, I'll leave it up to you.
Thank you. So as sorry, excuse me, as Jackie was discussing there, you know, you do all this work, you do everything for the machine and your products, etc., and your company. But what you need to do is you need to keep it up to date. You need to continually assess it, and that is part of the request of the machinery directive, is that you do keep yourself current, keep yourself up to date. So that's just something that has to be ongoing. So what I'm going to do now is I'm going to take you through a bit of a lengthy, try and bring a few things together. So what I'm going to do is take you through a practical risk assessment of an issue that was brought up by the HSE in the UK, and it is to do with slurry dribble bars. So in 2018, the HSE raised an issue with slurry dribble bar manufacturers, and that issue was inadvertent deployment of the folding elements of liquid fertilizer distributors. So what happened, what raised this issue was the arm of a dribble bar came down when it was on the road. It wasn't correctly stored for transport. It came down, and unfortunately there was an accident. And as you know, so what is a dribble bar, I suppose, as most people say. So this is the picture of the back of the or off the machinery, sorry, off the standard, very simplified picture of a dribble bar. So it's a folding bar with pipes that distribute slurry at a width, and then when you go onto the road, should that be on the back of the tanker as it is here, or on the back of a 3-point linkage on the tractor, it all folds into road width. And the issue was that because these arms were up in the air, unfortunately one of them deployed, and then there was an incident. So you have to do something to stop that. So with it, the first thing you want to do is conduct the initial risk assessment, and then you conduct to see, is there a risk? So you first of all determine, is there a risk? And then you conduct a compliance assessment using the relevant standards. You determine the control measures, you then reassess the risk, and if all that works out okay, if your risk is deemed to be low enough, you update the relevant essential health and safety requirements section. So what I'm going to do is I'm going to, as I say, this gets a wee bit wordy and complex here, but what I'm going to show is an actual practical example of working through a risk assessment for a product. So let's firstly conduct the initial risk assessment. So this is just a risk assessment sheet that I have, and again, if anybody wants the template, you're quite welcome to it. But so it lists the risk assessment number, the company, far and wide. What is it? Dribble bar. It's on the tanker. It can be either the 6, 10 or 12 meter. They're all built functionally the same, and the power supply is the tractor hydraulics. Again, you may want to add more information than that, but that'll cover this one off. So the next thing we want to do is look at the nature of the hazard. So the nature of the hazard is exactly what the HSE said. The machine could, in certain foreseeable conditions, allow the vertical folding elements to freely move from transport, which is vertical, to working horizontal positions, generating a risk. So in other words, it comes down on probably on the road, and it generates a risk then to other people. So we go back then to our scoring system, and we take the 4 areas and we'll score them one by one. So what is the likelihood of this happening again? I'm using my scores on this. So it's an even chance. It could happen. You could say it's probable or possible, but I'm going with an even chance. Frequency exposure. Well, again, if it was, I'm assuming that if it was on a 3-point linkage, that system might only come out of the field daily. You could argue that if it was on the tanker, it might be run up and down the road hourly, but we'll go with daily just for the purpose of this. Degree of possible harm. Unfortunately, we know that there was a fatality involved in this. So again, if you drove down the road with that arm out and you hit a pedestrian or hit someone in the car, there's potential to cause a fatality. And the number of persons at risk. Well, I mean, if we're out on the road, I've probably kept this number low, but I'm saying it could be up to 3 to 7. Either pedestrians walking or the contents of the vehicle can be up to 5, so it's between 3 and 7. So again, I hope you can see that we are just trying to put some sort of number on this. It's not an exact science, but we're putting a number. So what we're saying is we add those numbers together. Sorry, we multiply the 4 numbers together and we come up with a number of 375. And that's in the very high range. Now, you might do this and come up with extreme or high, but you can see where this falls in. So really you're showing that as an engineer, you've taken a look at this and you've assessed it and you've come up with some sort of number for the risk. So you must then, we've determined there is a risk, so it does require you to conduct a compliance assessment using the relevant standards. And what are the relevant standards? Well, here's 3 that apply. There may be more, but we are going to use these 3 for the purposes of today. So there's 4254 part 6, which is specifically for agriculture machinery, sprayers or liquid fertilizer distributors, which is exactly what this is. We have to also consider the general principles or general requirements for agricultural machinery. And then because there could be the slurry tanker involved, we do have to look at the slurry tanker standard. Again, the good thing is there are 3 specific standards which are hopefully going to tell us what we need to do. So I read the standards as you do on your days off, and I started to look at specific parts. So the part 6 standard, it says there is a specific bit about 4.3 spray boom folding. In the case of powered folding, unfolding operation, the control shall be of the hold and run type, and the manual controls should be located outside the swivel zone. That's actually repeated in the same statement is repeated in the 703 tanker standard, sorry, 707 tanker standard. What that tells me is you're not allowed to latch, so it can't be an automated process. The operator has to hold the tractor valve on to allow this to fold out fully and unfold. So to fold up and fold down, and it can't be where they can't be doing this from the back of the tanker or the back of the tractor. It has to be done inside the tractor, away from it. So spreading, another particular thing, so spreading or injection booms. In the case of powered folding, unfolding operation, the controls should be not hold and run type. Manual controls should be located outside the zone. Yeah, a device should be provided to prevent the boom from moving when in transport position. So that tells us, it has said there has to be some sort of device. The locking device and the boom folding, unfolding action shall be controlled by separate systems. So if you fold it up and then you have another ram pushing a pin in, or if you're physically putting a pin in, have to be 2 separate actions. It can't be a programmed, procedure. And if the locking device is a hydraulic valve, not fitted directly to the cylinder, it shall comply with, and again it quotes in the General Agricultural Standard, and it gives me a specific area to go to, and we'll go to that in a second. And what it's telling you there is that you don't necessarily need a pin. You can hold it with a hydraulic device on the cylinder. So in other words, you can, if there's some sort of burst valve or whatever, or creep valve, you can put it on. So let's go to this 411.3. So 411.3, when you go to that standard, again, I'm just following the chain. I'm following what the standard tells me. Hydraulic locking devices should be located on the hydraulic cylinder or connected to the hydraulic cylinder by a rigid or flexible line. In the latter case, the lines connecting the valve to cylinder shall be designed to withstand a pressure of at least 4 times the rated maximum of the hydraulic cylinder. So what it's saying is, if it's not on the cylinder and there's a line between this hydraulic device and the cylinder, it has to be 4 times rated. So there's a very specific piece of information that you must follow. The rated maximum hydraulic pressure shall be specified in the operator's manual. There it tells you to update your manuals. The condition for replacement of the flexible line should also be given in the operator's manual. So it's telling you that you need to put 2 lines of instruction in your manual when you're writing your manual. And again, some of this is done by instruction and some of it is done by physical device. So again, we keep going with the standard, and it talks about folding elements. So we're into 4.9. So folded elements designed to reduce transport width and or height shall have a means of retention in transport position, either a positive mechanical lock or by other means, hydraulically or gravity. We've just talked about the hydraulic version, and gravity is that you're going over center, but you have to decide by how much over center you go. The means of retention shall be sufficient to retain the fold element in the transport position during travel. So if you're just relying on gravity, you have to determine how far over center you're going. The change from transport position to working position and vice versa shall be possible without exposing the operator to the crushing or pinching. So in other words, operator should be well out of the way, as we talked about before. And in the by the way, sometimes standards repeat themselves. They just say the same thing differently, but you've got to go through it and just read them all. In the case of mechanical or hydraulic locking devices, the unlocking and unfolding of the elements shall be controlled by means of a separate action by the operator. It said that before in a different way. In other words, you control those 2 rams differently by different times and different valves. And then it talks about, so it's talking here about not in the transport mode, it's talking about in service or maintenance. So supports for service require that the device should be applied from outside the hazard zone or be a different color or surrounding structure and be sufficient strength described in the manual to be retained on the machine and be designed to prevent inadvertent locking. So what it's saying is, either if you're using the same locking device for maintenance or there's a different locking device, you have to clearly mark it, and it's supposed to prevent inadvertent locking and that it can't creep into position or whatever. Mechanical locking device is the preferred option when working below the raised part, and it has been designed to withstand the forces as can be seen to be attached. So again, it has to be strong enough to hold the whole product up or hold product in place, the whole arm in place. Alternatives are gravity locking mechanisms or hydraulic lock valves. Again, if the hydraulic means of retention are chosen, they need to be additional of any hydraulic locking devices in the tractor. In other words, you can't rely on the tractor's valves to hold this up. It's saying that it's not sufficient to say, oh, well, there's a, the tractor valve will hold this. It's saying it has to be on the machine. And the hydraulic locking valve of the tractor to which the machine is fitted should not be taken into consideration when required safety standard of the machine. And you do not know what the tractor, it says, as you do not know what tractor your machine is connected to be fitted with a lock valve. So what it's saying is, you have control of what you send out of your factory. So if you send out a locking device on your machine, fitted to your machine, you know what it is. Whereas if I was doing this with a 40-year-old Ford County or whatever, the hydraulics in it are very different to a modern day Fendt or whatever, or John Deere. So you can't rely on that. You have to put it, it's telling you to put it on the machine. So what you need to say is, right, I've went through all that. I've determined there's a risk. I've assessed that risk, and then I have looked at what the standards are telling me to do about that risk. So I'm going to determine a control measure and then reassess the risk. So again, you may do this very differently. I'm probably doing this with a bit of overkill here. You might do it differently, but I'm doing it for the purposes of what can be done. So the recommended control measure, still the same risk assessment. We're in the second part of it now. Redesign the folding sections of the boom to travel past vertical by 30 degrees and rest on mechanical stops. So I'm saying 30 degrees past vertical is enough to hold it. Again, you'd have to determine that. I'm not saying that's right. Add valves to the folding rams. So in other words, we're going to add hydraulic valves. Add hydraulic horizontal locking rams, red in color with 50mm pins. So that's to do with, yes, it's going to lock it in place, but it also potentially can be used for the maintenance side of things if that's what you want. But it did say it had to be a different color, and I have specified the size of a pin. Separate hydraulic controls in the tractor for locking rams. So again, there has to be 2 separate pipes come to the tractor, one for the locking ram, one for the actual folding ram. It did tell us to update the instructions for operation and highlight the need to ensure the area clear of personnel, include specific hydraulic locking valve instructions and associated paperwork. So the 2 things are way back earlier on, or not way back earlier on, and it told us to put in the instructions. We are going to list those in the instructions. So these are the recommended control measures that I or you or whatever have come up with. And again, you've detailed them out so someone can see your work. If someone questions this, they can go in and look at this in more detail. So let's redo. So we rescored now. We assume everything has been put on this machine, we rescored. So the likelihood of occurrence, we have dramatically reduced. It's now highly unlikely. It's not impossible, but it's highly unlikely with all that stuff in there. Still, frequency is daily. That doesn't change. It's still the frequency of when it can happen. The degree of possible harm is still fatality if it did happen, and the number of persons doesn't change. So the only thing that has changed is we have brought the likelihood of occurrence way down from and then if we multiply those numbers, we are now have multiplied those and come up with a hazard rating number of 7.5, which, as you can see, is in the low area, and the degree of risk is low. So as an engineer, you're saying that is acceptable. Now, again, I'm using a lot of poetic license or artistic license here, but what I'm trying to show you is the principle of how you do it. So what you do is you do it and you rerun it, and then, as I say, you document what you've done and you rerun the risk assessment and you come up with a solution. And again, I've done it in 2 halves there, but this would be your risk assessment as a 1-pager with the nature of the hazard, your first assessment, which was very high, your recommended control measures are all listed out. You might put in drawn numbers, etc., and all in there. Then reassessment is low, and then you document. So you go off and you document that as your risk assessment to cover that off. And that's what risk assessments would look like across all things. Some of them will stop because in the first section you'll come out with a low, very low, negligible, so you won't do. There's no need for a control measure in it. So that is the risk assessment. So we're not finished. We've done our we've conducted the initial risk assessment. We've then looked at how we can actually comply. We've gone through the standards. We've looked at compliance. So now we need to update a few things. We need to update the relevant essential health ESHRs. We need to update those. So in the ESHRs, when you go and read through them, and I'm sure you're all going to rush to read through them after this is finished, but these are the sort of sentences that are in them. So it says machinery must be designed and constructed so it's fitted for function and can be operated, adjusted and maintained without putting persons at risk when these operations are carried out. And way down there, I've highlighted this bit, during phases of transport. So our risk assessment was number 24. So number 24, instead of you rewriting out your action and all, you can just refer to the risk assessment. You can say, you could write your actions out there, but you can just go and look at the risk assessment. It's covered that. And I mean, there may be multiple. I've made a fictitious number 10 up there as well that has something to do with this. But if I'm trying to follow the ESHR report, I can then go and click on these risk assessments. Again, you could have links in there to them if you wanted to be very fancy about it. Then it says another bit, it talks about selecting an appropriate person must apply the following principles. So one of those is inform users of residual risks due to any shortcomings of the protected adopted measures. And I have said in my action that I have updated my instruction manual in those sections, and that is related to risk assessment, again, number 24. So updated the SHRs, updated the instruction manual, and there's a risk assessment showing my thinking behind all of this. And then you must design of machinery to facilitate its handlings is 1.15. So again, it must be capable of handled and transported safely. So again, that is relevant to this risk assessment number. And then during, and this is a very specific bit in 1.1.5, during the transport of machinery and or its component parts, there must be no possibility of sudden movements or of hazards due to instability, as long as the machinery and or its component parts are handled in accordance with the instructions. So again, we've updated the instruction manuals about how to lock it in place, and during transportation, that risk assessment applies. So again, what you would have is, so it says just below that, this isn't part of this, but it says when it's been moved that, you know, it must be fitted with the correct attachments, etc. So I've just put in an action there that there is lifting points, and that relates to another risk assessment. So again, you would be filling all of these in. Every one of these that are relevant would be filled in, but I'm just showing you how you compile your ESHRs and relate your standards and your risk assessments to it. So again, with this one, we go into 1.2, which is the control systems. Control systems must be designed, constructed, and situated to prevent hazardous situations from arising. We did that in this with the separate valves for the pin and the separate valve for the folding ram. And then also no moving part of machinery or piece held by machinery must fall or be ejected. So the boom did fall originally, or could have fell, so we have addressed that. And again, we keep going through the ones, and I'm picking out the ones that are relevant. I've just picked out, as I say, there's reams and reams of these, but machinery components and fittings must be stable enough to avoid overturning, falling, or uncontrolled movements during transport, assembly, dismantling, or any other action involving the machinery. So again, that risk assessment is relevant to transport. And again, then risks during falling or ejected objects in 1.3.3, we've covered that. Again, could be a falling object. And then way on down, 1.7.4.1, it says contents of instruction, description and explanation necessary for use, maintenance, and repair of machinery. And I have said that instruction manual in section 8, it talks about the locking device. So that is what you're trying to do there is you're trying to summarize your actions in your essential health and safety requirements report. So in other words, someone can follow this and go and look at your risk assessments. And by the way, this isn't all you would do for a dribble bar or a tanker. You would be filling in loads of these, but again, you are trying to reference the reader back to what you have done and why you have done it. I think we're going very well for time actually here, so I'm just going to keep talking. We're probably getting closer to the end a bit earlier today, but that's a good thing. That's a good thing. So that kind of is the end of my presentation around the machinery directive. I've taken you through what can apply, when it can apply, how you use standards to meet the requirements, the documentation you need to keep in technical files, the documentations you need to issue to your customer, your legal requirements. I've given you an example of how to do a risk assessment. So what I'm trying to give you there is as much information that you can go off and check what you've done to date, or if you're a new machine manufacturer who's sitting listening today, hopefully this will give you some guidance on where to start. And as I say, my slides will all be available. So it's a high level, well, semi-detailed high-level overview we're given today on the Machinery Directive, and hopefully it has guided some of you towards it. But do remember that your product can fall under multiple ones, and what I would suggest is always do sign up to our webinars on the electrical one, which was last week. As I say, Simon gave lots. I didn't really go into the detail of how to control machines and all to do with electrical control and control devices, because Simon goes into a lot of detail in his seminar. So I would suggest you would go and listen to that or get the slide deck for that one, because there's no point in me regurgitating what Simon's saying on those. So that is as far as particularly when you get into e-stop, safety devices, etc. He gives lots of details on that. So that is the Machinery Directive coming to conclusion. But as ever, and it's not like Europe, but Europe has decided to make a big change. And the big change is the new machinery regulation will be replacing the Machinery Directive on the 20th of January 2027. So the next time I'm talking to you this time next year, you'll have a couple of months only to get ready. Hopefully you're well ready to comply. And I'll talk you through briefly there's about 8 slides here on what's going to happen and the differences. It will affect some people worse than others and some people not too bad, hopefully. So it's coming in 20th of January 2027. There's no provision to use it before that date. On the 19th, you use the Machinery Directive. On the 20th, you use the Machinery Regulation. That's the way it works. And it will align with the whole new legislative framework in Europe. There's lots of directives being updated and brought under this new legislative framework. So, why is change needed? Well, the old Machinery Directive was designed in the days, and it goes way back, was designed for machines with fixed yards, gears, motors, and maybe at best standalone PC or PLC control, which was not connected to the World Wide Web, which didn't exist. The machine, you walked over to the machine with a floppy disk and you programmed it and stuff. So, and yes, that has evolved, but that was the original Machinery Directive was devised for that. So modern machines have, which is quite a new thing, but they have the ability to learn. A lot of them are connected to the cloud and other various things out there in the World Wide Web. They regularly get background updates over Wi-Fi and other networks, which sometimes we don't know anything about. And remote diagnostics can be accessed by third parties. So I was recently getting my car, a fault came up in my car, and BMW said I didn't need to bring it in. They could easily access the car from where they were sitting and where the car was sitting. So, what this new regulation, one of the primary functions of it, it's going to bring into line AI, cybersecurity, and also digital documentation. So the theory is, if you can access the machine remotely, someone else can access it remotely, and a bad person a hacker can access it remotely. So there are new provisions for machinery with safety functions that are AI or learning powered. There are new provisions for cyber safety, for compliance, relevant software, and safety control systems. If these apply to your machine, you will need a conformity assessment by a third-party notified body on those control systems. Now, again, this is where you get into, well, if I am supplied those by another company who supplies those, how do I comply? That's something you're going to need to determine for your machine. A lot of people are sitting here today, this bit doesn't affect you because you're not controlling by software, you're not connected to the internet, you're not connected wirelessly. So if it's wireless in any way, you will need to consider this. Safety components will now include software, so you can control safety by software almost exclusively sometimes. A conformity assessment procedure is required for machinery safety if the machine undergoes major modifications. This is a change. There always was a grey area in the Machinery Directive around, well, if I modify a machine, who's responsible for it? At the end of the day, the person that undertakes the modifications is still responsible. So you could sell a machine and in 5 years' time, somebody significantly modifies that machine. Or you could have a machine in your factory which you considerably modify, you will, or they will need to carry out a full reassessment and effectively CE mark the machine themselves. So that is more formally laid out in the new machinery regulation. Generally won't affect the original manufacturer, but if you're asked to go back and update a machine or modify a machine, you will have to consider that. It's easier for you to do than someone who didn't originally build the machine. And the other change that will affect all of you is documents must be provided in digital format. They're going digital. Paper documents, it's not that they can't be sent, but they're no longer be sent paper. They're going to have to be available digitally. You're going to have to put them up and be available for the customer to access. And that could be a QR code on the machine or whatever, where they click in and they can download the manual, which is a good thing because everybody loses the manuals. So legislation and standards, I'm actually going to a meeting later on today about this, but the EU will implement the regulation on the 20th of January 2027. That's going to happen. They've said they're going to do it. It's in some of the statute books. They're going to do it. GB is currently carrying out consultations on what changes they need to make on how to address non-alignment with the EU. So they're going to have to determine what they're going to do, because this is a big change and they are effectively falling out of alignment because their supply machinery regulations was based on the machinery directive, not on the machinery regulation. Northern Ireland will need to make the necessarily legislative changes if they want to continue alignment with the EU. So we do align with the EU on this, but that can't happen until the legislative changes are brought in and are applied. So that needs to happen. That's totally out of my control, your control, everybody's control, but that has to happen. The other big thing that has to happen, we talked earlier about the two bodies who create standards, CEN and CENELEC. CEN and CENELEC have approximately 800, I think it's more, but they're saying it's 800 harmonised standards that must at least be reviewed and, if necessary, adopted to the new machinery requirements, the new requirements of the machinery regulation. I mean, some of those are very minor changes. Some of them are quite big. A lot of them around, probably CENELEC is going to have more to do than CEN because they would do more of the electrical ones. But again, you're going to be looking at your standards. Your version of the standard is going to say machinery directive, and you're then going to be working towards machinery regulation. So again, this has to be addressed, and time's running out for this to be addressed. So how do you get ready? What's the practical things you can do now? So if your machine has safety related AI or machine learning, it will be considered high risk. If your machine is wirelessly connected, then there's a cybersecurity risk and it will need third-party certification. So lots of companies are currently getting cybersecurity through Cyber Essentials, etc. The machine is going to be required. The theory behind it is, if you or me can dial remotely into that machine or connect wirelessly to that machine, someone in theory can, and then they can make it move. And again, it says in the line below, your assessment must consider unpredictable behavior and evolving logic. So unpredictable behavior from a hack, which you want to stop the hack. And then also, if logic is evolving, you have to think about, do I trust that logic, or how can I trust that logic? Again, most people won't be affected by this because they don't have that level of control. But there are a lot of companies here who make very specialized and with machines with a lot of control on them, and they will be affected. You will have to include cybersecurity in your risk analysis in the technical file. And as I say, that could be a case of saying cybersecurity doesn't affect me, or cybersecurity does affect me, and here's how I covered it off. The essential health and safety requirements need to address the whole life cycle of the machine. That's more formalized now. They always did, but now it has become more formalized right through from design to decommissioning. And there is more, you'll be joyous about this, there is more legislation coming in around life cycle of machines and stuff, and that is going to be for everything. That is for household goods, machines. So life cycle is going to have to be considered when you're scrapping a machine, etc. or when a machine is decommissioned, reused, whatever. So you will need to address that again. Some people that'll be quite easy for, some people that may be more difficult for, depending what your machine does and what it's made of. So as I was saying earlier, customer documentation must be sent digitally. So your manuals, your declaration of conformity will all have to be available to your customer digitally. I mean, how you transmit that to them. I mean, when they buy the machine, they can sign up and you can send them it out by email, or again, if someone's using the machine and there's a QR code on the machine, they will be able to click on the QR code, scan the QR code, and go to your site. And download a copy of your instructions. The other thing is your technical file, if it is digital, it needs to be complete, obviously. It needs to be accessible by whoever needs to access it, but it needs to be secure as well, so someone can't tamper with your documentation. And that's the same with all your stuff. You will need to keep your files safe. So probably this is mostly what will affect you, is you get your paperwork digital, which most people have. At the end of the day, we're creating it in Word and then making a PDF out of it, and that's fine. You can send out a PDF. Your declaration of conformity are generally created in Word and then saved as PDF, so they can go digital. You will need to host those somehow that people can access them. And then, as I say, your technical documentation will be digital. If the HSE or someone come in, they can request digital copies, etc., of these. So you need to bring everything into line. So that is a new machinery regulation. We hopefully maybe will do something during the year in this. We'll maybe try and do some sort of awareness webinars, etc., to make people more aware. We are always available for advice if anyone wants some advice, either on the machinery directive or new machinery regulations. Future seminars, this one's just about to finish. We're going to go to questions soon, so that's the mechanical one. As I say, the electrical one was last week. And then next week is going to be the global technical compliance, which is, I've just talked about all things EU and CE, but if you're going beyond, CE is only applicable in the European Union and a few other places. So if you're going to Australia or America or wherever you're going with your machine, then you need to consider global technical compliance. And there is a seminar coming up on that, and I'd suggest anyone listening to that. So Barry, that is about me coming to the stage where my presentation is finished.
Brilliant.
So I don't know if there's any questions.
There is.
We're a bit early today, but anyway.
Yeah, we've done well time-wise. That's a lot of talking from you, but you're not done yet. We have a question in which says, when you update the ESHRs following the risk assessment, do you solely review according to the EHSRs stated in the harmonized standards applied, or would a full review of EHSRs be necessary?
I know what they're saying. Yeah, so in the back of the standard, what it'll do is if you go into the standard, a lot of them will quote the actual ESHRs that apply to your machine. So that definitely, those all need reviewed. But again, it can sometimes what I would say is, when it comes to things like instructions and stuff, in the back of standards, they'll kind of just maybe say 1.7. They won't give specifics. So you do have to kind of not go through it all in the nth degree, but you do have to look at it all again. But they're right. The person's right. In the standard, it tells you the ones that apply to your machine, but you should have a general scan through, particularly on things like guards and on things like instructions, where you just have to check off that you have covered all off. But they're right in what they're asking. It is mostly the ones that are noted in the standard, but unfortunately, with everything in life, that doesn't cover you. But yeah, they should be okay with doing the ones in the back of the standard.
Super. No other questions in yet. So a small number of questions submitted today, but actually all really good, detailed questions.
Yeah.
So thanks to everybody for submitting, because it's good to get some of these things teased out in detail. I'm going to keep an eye on it, but I can't see any other questions in. So maybe at this stage, Pierce, thanks very much. You get a bit of a break now, and I'll hand back to Colin Graham from Invest NI just to do the wrap up and close.
Okay, thanks very much, Barry. Just remains for me to thank Pierce and Jackie for their excellent presentations this morning, and especially to thank Barry Folina from Eventful for hosting the event and for posing the questions. Thanks most of all to everyone who registered and participated and posed those questions to us. We hope you found it worthwhile. And as Pierce mentioned, just a final reminder about the last half-day webinar, which is next Thursday. That might be of interest to you or to some of your colleagues. So if you'd like to register for that, just go to investni.com/events, and it's free to attend if you would like to hear more about global technical compliance requirements in the main global markets beyond the UK and the EU. That's it for today. Thanks very much for taking part and for attending, and hopefully we'll see some of you online next week. That's it. Thanks very much, everybody, and that's the end of today's webinar.